An Introduction to the Philosophy of Marxism. Part IRS. Baghavan. First published as a series of articles in the Ceylonese Young Socialist magazine, 1962–1970. With a foreword by C.L.R. James. Foreword. This is an admirable introduction. It introduces and at the same time it deals adequately with its subject. It has, however, one serious omission: it does not take its subject into distant seas as yet uncharted. I am to do an introduction to it. And that, in view of the tight comprehension of what I read, this is a task requiring space, to in gaps and expose unsuspected relations. This is beyond me and beyond my present perspectives. I shall therefore limit myself to presenting the subject as I see it. Marxism is the climax of the thinking of Western Europe. It is today an integral part of the thinking practice of Western Europe. Neither of them, the thought of Western Europe nor the Marxist complexity, can be understood unless seen in relation to each other. Marxism is a climax. But when Marx began, Western literacy had already reached ultimate stages in its different disciplines. Hegel had brought philosophy to a peak from which it was obvious there would be no new risings and plateaus. The business had reached its pinnacle and could no longer continue in those waters. In the intellectual activity and discipline of history a climax had been reached with Michelet. History as a narrative of interesting events and dramatic personalities could go no further. It is interesting to note that the criticism of Sainte-Beuve was recognized by the acute as the ultimate of a practical style of criticism. To the achievements of literary observation and analysis Victor Hugo had added poetry to scholarship and illumination to both. It is this niched achievement in various spheres that the youthful, educated and ambitious young Marx faced at the beginning of his entry into the literary and historical world. As we can see today, and it would be rash to believe that Marx did not see it and was working by instinct, we can see today that literature could advance, not by going further along the road or roads it was traveling, but by dramatic movement, what the master of phrase Hegel had designated as a leap. What is most striking today is the fact that Marx did not have to struggle and laboriously explore the ground in order narrowly to see a clear road. He was a very educated young man with a mastery of the classical languages and the literature and history of Western Europe. He seemed to understand that there was no further development along the established lines, and in the Communist Manifesto he said, or rather he showed, that he fully understood the new height that had been reached. Even to this day I must confess that no excitement in literature or history exceeds the excitement that attends a grasp of what was done in I-848. Attempts have been made to show anticipations of the great discovery. I do not envy them convincing. My belief is that Marx was already a master of all that literature and history and philosophy had achieved. Thus, for him, it was natural to leave it all behind and state the new requirements that the art demanded. There have been many leaps from one stage to a higher stage in the progress of European history and literature. I don't believe that any of them in dramatic significance and result exceed what Marx did in 1848. Let me explain what I am doing. I was requested to write a foreword to this introduction to the philosophy of Marxism. The introduction is a very capable piece of work, being very much aware of the development of social theory and philosophy. There is an exceptional mastery of the details and a cadence which shows that the material has been mastered. I am, however, personally very much aware of how easy it is to forget that Marxism, the insight into all kinds of intellectual achievements, is the result of a discipline, a construction by the human mind developed from contacts with the various events and historical development of the world outside it. Never must this be forgotten, in particular that the outside world is constantly changing and enlarging itself, imposing similar consequences upon the intellectual discipline. I end with what I began. The real beginning of the Marxist movement is in the writing of 1847 and 1848, and those are the direct result of the events of 1847 and 1848. Marx never went beyond that for the simple reason that it was impossible to do so. CLR Fames, March I 987. Chapter 1. Preliminary. Neither Marx nor Engels claim to be philosophers, though it is significant that Marx chose as the subject for his doctoral dissertation the philosophies of Democritus and Epicurus, the materialist atomists of ancient Greece. Engels, who had, in 1842, published 2 critical articles about the philosophy of Schelling, when addressed as doctor and requested to contribute to a radical magazine, declined, protesting, "I'm only a merchant and a Royal Prussian artillerist." Marx and Engels described their philosophical outlook as their method and sometimes as the only scientific method, and did not give it a name. In 1886, after Marx's death, Engels wrote, "This materialistic dialectic has been our best working tool and our sharpest weapon." The inverted phrase dialectical materialism was coined by Plekhanov, who is also responsible for the statement that Marxism is an integral world outlook. Philosophy, as Lenin emphasized, is a component part of Marxism. Marx fused the dialectical method of Hegel with the materialism. It has been observed that Hegel passed lightly over the early materialists and that Marx made the RST, and for a long time, the only, study of their ids. Let us note, however, that after 1842 Marx lost interest in the publication of his thesis. It was published only in I-902, long after his DTH. In fact, the original has been lost, and what has been reproduced is an incomplete copy with corrections by Marx. Introduction to Philosophy of Marxism, culminating in the work of Feuerbach, and in so doing, made the greatest single philosophical contribution to human thought. Only Marx could have done that, said Engels, his collaborator for 40 years. Marx stood higher, saw further, and took a wider and quicker view than all the rest of us. Marx was a genius, we others were at best talented. Without him the theory would not be by far what it is today. It therefore rightly bears his name. Degree. Through the years critics have accused Marx and Engels of not having set out their philosophical method in a self-contained work. Where, they demand, is the book? 7 Marx had hoped he could write one. In 1858, he wrote to Engels, "If there should be time for such work again, I should greatly like to make accessible to the ordinary human intelligence in 2 or 3 printers' sheets, what is rational in the method which Hegel discovered but at the same time enveloped in mysticism." In 1876, writing to Joseph Dietzgen, he expressed the hope again, "When I have shaken off the burden of my economic labors, I shall write a dialectic." The correct laws of the dialectic are already included in Hegel, albeit in mystical form. It is necessary to strip it of this form. In 1873, Engels began working on a more, in fact, a very ambitious plan, which, unfortunately, he was compelled to drop in 1886. He left us fragments and unused drafts which were published under the title Dialectics of Nature only in 1925, 30 years after his death, and unfortunately, also, after the deaths of Plekhanov and Lenin. Marx and Engels developed their philosophical method in works that were critical and polemical. Their joint works, The Hoppe Family and the German Ideology * were critical studies of post-Hegelian philosophical trends. Marx's The Poverty of Philosophy was a reply to Proudhon's The Philosophy of Poverty and may be justly retitled Anti-Proudhon. Published posthumously. Admittedly written for self-clarification, Marx later wrote that unable to end a publisher, they left the manuscript to the gnawing criticism of the mice. Degree. His was unfortunate. As here Marx and Engels used evolutionary ideas long before Darwin. Preliminary. 3 later years, Engels wrote Anti-Dung, again a polemical work. The point critics avoid is that one has to have a philosophical position in order to polemicize against other schools of thought. As Antonio Labriola has reminded us, Marxism, like any other idea or school of thought, did not drop, ready-made, from the sky. Marx himself observed, as early as 1842, that philosophers do not grow out of the soil like mushrooms, they are the product of their time, and of their people too. In another eld of thought, Freud has remarked that Complete theories do not fall from heaven, as Engels noted. The science of thought is a historical science. Marx developed his philosophical method in the late 30s and the early 40s of the last century. Hegel wrote under the intellectual impact of the Great French Revolution. Marx began working at the time of the RST independent stirrings of the working class and under the impending impact of the West European Revolution of 1848. Marxism was developed not only in critical contact with traditional concepts and prevailing ideas, but also in anticipation of historical events. Answering the critics, Lenin observed in his Philosophical notebooks, if Marx did not leave behind him a logic, he did leave the logic of capital, and this ought to be utilized to the full in this question. In Capital, Marx applied to a single science logic, dialectics and the theory of knowledge of materialism, which has taken everything valuable in Hegel and developed it further. 5. In his review of the German edition of the Marx-Engels CM Respondums, Lenin commented, if one were to attempt to define in a single word the focus, so to speak, of the whole correspondence, the central point at which the whole body of ideas expressed and discussed converges, that word would be dialectics. It is worthwhile recalling here Darcy W. Thompson's observation that though the ancient Chinese never set out their chemistry, it is there in their papers and ink, silk and porcelain, and their gunpowder. 7. The reference is to Hegel's Science of Logic. 4. Introduction to Philosophy of Marxism. Just as Sir Isaac Newton did not leave behind him a textbook of science, but did give us a Principia, Marx and Engels have left us a rich heritage of applied dialectics with materialism as their fundamental premise and dialectics as their method of investigation. They made brilliant analyses and prognoses of history and economics. But the disadvantage is that a wide field of reading has to be covered before one gets a general idea of Marxist philosophical concepts. It has been the practice of most writers on the subject of Marxist philosophy to follow the historical method of presentation. This method, which would be proper in a biographical or historical study, is hardly suitable for an introductory exposition of Marxist philosophy. The reader is not likely to be interested in following Marx and Engels through their polemics against various 19th-century philosophers, most of whom have passed into obscurity and would not even be remembered today if not for Marx and Engels. This introduction is didactic, the treatment is schematic and not historical. The laws of the Marxist method are presented and illustrated, for the sake of brevity, by a few examples. Dialectics being universal, there is no limit to examples. With a multiplicity of them, the reader would be unable to see the wood for the trees. It must also be noted that quotations are used here, not as invocations of authority. Marxism knows no sacred texts but as niched expressions of the ideas to be conveyed. We might note with Trotsky that no one has presented Marxism better than Marx himself. Chapter 2. The task posed by history. Statement of the problem. The echoes of the Great French Revolution had hardly died away when independent movement of the proletariat began. As Engels noted, the proletarian ideas of Gracchus Babeuf had already cast their fateful shadow beside the bourgeois thought of Jean-Jacques Rousseau. In 1831, an uprising took place in Lyons, France. Rallying under the slogan, "Live Working or Die Fighting," it was the RST independent action of the working class in history. In 1838, the English proletariat launched its Chartist movement, with less romantic and more down-to-earth slogans, one of which was, "More pigs, less parsons." In 1844, the Silesian weavers heralded the revolt of the German working class, a revolt, which, as Marx observed, contemporaneously, was directed not immediately against the King of Prussia, but against the bourgeoisie. Everywhere in Western Europe, while industry was making feverish progress, the workers were raising their heads. Outbreaks of the class struggle regularly disturbed the normal functioning of national politics. Radical intellectuals, shadowed by insecurity, shifted from one philosophical position to another, sometimes irritated with shades of socialism, but generally ended up either in verbose task posed by history 7 potents or as shameless agents of the ruling classes. The exceptions were few. In 1845, One of them, a 27-year-old German, already an exile in Belgium, wrote in his notebook, "The philosophers have hitherto only interpreted the world in various ways, the task, however, is to change it." 3. The young man was Karl Marx, and the success with which he applied himself to the development of the theoretical basis and the practical aspects of this task is clearly indicated by the fact that his work has inspired gigantic social movements all the world over, while the bourgeoisie and its servants still direct towards his memory and his followers their unrelenting hatred. I.e. philosophers have hitherto only interpreted the world in various ways, the task, however, is to change it. Let us note, however, that change occurs everywhere, and at all times, and also independently of the activity of men. All inorganic matter, once molded into shape by nature or man, is subject to erosion and decay. Birth and death is the basic rhythm of life. The ancient Greek philosopher, Heraclitus of Ephesus, illustrated the universality of change with the aphorism that one cannot bathe in the same river twice. Later, Critolus, more expressively, emphasized that one cannot bathe in the same river only. Society too changes, but imperceptibly most of the while. Unitask is to participate in this change, to give it conscious and active direction. It is, therefore, necessary to study the phenomena of change. The formulation of the laws of change in general will guide us in establishing the laws of social change. And this is exactly what Marxist dialectics has done for us. As Lingels noted, dialectics is nothing more than the science of the general laws of motion and development in nature, human society until thought. 5. Once we know the laws of change in human society, we can see where and how our activity may be integrated into the process of change taking place, for the reorganization of society is the crying need of our time. Chapter 3. Materialism. The basis of Marxist philosophy is materialism, and the essence of materialism is not at all difficult to understand and accept. Thomas Lusley once wrote, "As long as we actually observe and think, we cannot possibly get away from materialism." 1. Marx quoted these words approvingly in a letter to Engels. The word materialism is easily understood, the more so because, in Marxist terminology, all non-materialist schools are termed idealist. Nikolai Bukharin drew a neat distinction between philosophical materialism and idealism and practical materialism and idealism. Marxists, he observed, are materialists in philosophy and idealists in practice. 3. Philosophical materialism is not a crass self-dedication to the material things of life, but a point of view which asserts the primacy of matter. Marxists proceed from the recognition of the world as a reality independent of human consciousness. And not Marxists only. This view was expounded by some ancient philosophers in China, India, and Greece. In fairness to Thomas Huxley, we must mention that he described himself as an agnostic, a word which he coined. Some of the non-Marxist writers quoted here were not consistent in their materialism. When Europe awakened after the intellectual slumber of the Middle Ages, philosophers began once again to expound this fundamental idea, but it was Marx who gave it clear and niched expression. In his Materialism and Empirio-Criticism, Lenin deemed matter in the Marxist philosophical sense. Matter is a philosophical category designating the objective reality which is given to man by his sensations, and which is copied, photographed, and reacted by our sensations, while existing independently of them. He repeated, the one property of matter, the assertion of which deans philosophical materialism, is that of being an objective reality existing apart from our consciousness. 5. With the advance of scientific knowledge, this position has been acknowledged by non-Marxists as well. Anton Chekhov, who was also a physician, observed, to forbid a man to follow the materialist line of thought is equivalent to forbidding him to seek truth. Outside matter, there is neither knowledge nor experience, and consequently there is no truth. Albert Einstein has said, all physics is realistic insofar as it starts from the hypothesis of a reality independent of perception and thought. And again, conviction that the external world exists independently of the observer investigating it constitutes the basis of the whole science of nature also. All knowledge of reality starts from experience and ends with it. 9. Another famous physicist, Max Planck, wrote, "Belief in some sort of reality outside us alone provides the necessary point of support in our aimless groping." 1 degree. And also, theoretical physics assumes that events exist independently of our senses. Still more forcefully, Planck expressed the concept of materialism in the form of theorems. Now there are two theorems that form together the cardinal hinge on which the whole structure of physical science turns. These theorems are: there is a real outer world which exists independently of our act of knowing, and the real outer world is not directly kn0 wabble 2. The primacy of matter. Scientific investigation has definitely and unquestionably established the fact that living matter originated from non-living matter. Though science has not yet determined the exact mechanism of the materialism li process, the evolution of life from inorganic matter is an established fact. And life, at a certain stage of its evolution, produced the mind. There have been three broad stages in evolution on Earth: non-living matter, living and thinking matter. The process has taken ages. Present estimates are: age of Earth, c. 4,500,000,000 years. Age of life on Earth, c. 0.2,000,000,000 years. Age of man on Earth, c. 1,750,000 years. The human mind, then, has not existed from the beginning of time. It is a product of nature and is conditioned by society. Engels, summarizing Feuerbach, wrote, "Matter is not a product of mind, mind itself is merely the highest product of matter." Moreover, mind is not only a product of matter, it is also inseparable from matter. As early as 1651, Thomas Hobbes in his Leviathan declares, "It is impossible to separate thought from matter that thinks." 15. This, in a nutshell, is the meaning of the concept of the primacy of matter *. Ideas are a reaxion of reality. Marx wrote, "It is not the consciousness of men that determines their existence, but, on the contrary, their social existence that determines their consciousness." And again, "To me, the idea is nothing else than the material world recreated in the human mind and translated into forces of thought." Lenin elaborated this view: "This is materialism. Matter acting upon our sense organs produces sensation. Sensation depends on the brain, nerves, retina, etc. i.e., on matter organized in a finite way. The existence of matter does not depend on sensation. Matter is primary. Sensation, thought, consciousness are the supreme products of matter organized in a particular way." 9. The process of scientific knowledge has shown the correctness of Marx and his materialist predecessors in maintaining that ideas are shaped by the world of reality by one's biological, historical, social, physical, and psychological background. Thomas Huxley commented, "Surely, no one who is cognizant of the facts of the case, nowadays, doubts that the roots of psychology lie in the physiology of the nervous system." 2 degree. Erwin Schrödinger, the famous physicist, has written, "The RST observations of nature by primitive man did not arise from any consciously constructed mental pattern. The image of nature which primitive man formed for himself emerged automatically, as it were, from the surrounding conditions, being determined by the biological situation, the necessity of bodily sustenance within the environment, and the whole interplay between bodily life and its vicissitudes on the one hand and the natural environment on the other." 2 Trotsky observed, "The human mind is a product of the development of matter, and at the same time it is an instrument for the cognition of this matter. Gradually it adjusts itself to its function, tries to overcome its limitations, creates ever new scientific methods, imagines ever more complex and exact instruments, checks its work again and yet again, step by step penetrates into previously unknown depths, changes our conceptions of matter, without, though, ever breaking away from this basis of all that exists." 22. The fundamental question of philosophy: idealism or materialism. Although this materialist philosophical position was expounded by some thinkers, many other philosophers, both before and after Marx, held idealist positions. they maintained that ideas were supreme and that reality was fashioned after the idea. René Descartes declared, "I think, therefore I am." 23. Schopenhauer maintained, "The world is my idea." 24. For Hegel, the world was the realization of the absolute idea. There is nothing but the idea is all realizing. 25. In contrast, Marx declared, "I am a materialist and Hegel is an idealist." Hegel's dialectic is the basic form of all dialectic, but only an it has been stripped of its mystical form, and it is precisely this which distinguishes my method. In 1873, Marx repeated his position, "My dialectic method is not only different from the Hegelian, but its direct opposite." To Hegel, the life process of the human brain, i.e., the process of thinking, which under the name of the idea, he even transforms into an independent subject, is the demiurgos of the real world, and the real world is only the external, phenomenal form of the idea. With me, on the contrary, the ideal is nothing else than the material world collected by the human mind, and translated into forms of thought. And again, the mystication which the dialectic suffers in Hegel's hands, by no means prevents him from beginning the RST to present its general form of working in a comprehensive and conscious manner. With him it is standing on its head. It must be turned right side up again, if you would discover the rational kernel within the mystical shell. 3. The basic difference between idealism and materialism was deemed by Engels, the great basic question of all philosophy, especially modern philosophy, is that concerning the relation of thinking to being. Ideas to nature. Which is primary, ideas or nature? The answer the philosophers gave to this question split them into two great camps. Those who asserted the primacy of ideas to nature and therefore in the null instance, assumed world creation in some form or another, comprised the camp of idealism. The others, who regarded nature as primary, belonged to the various schools of materialism. 3. Trotsky summed up, the whole basic strength of Marx's method was his objective approach to economic phenomena, not from the subjective point of view of certain persons, but from the objective point of view of the development of society as a whole, just as an experimental scientist approaches a beehive or an anthill. For economic significance is what and how people act, not what they themselves think about their reactions. At the base of society is not religion and morality, but nature and labor. Marx's method is materialistic, because it proceeds from existence to consciousness, not the other way around. 32. Chapter 4. Change is the only absolute phenomenon. While recognizing the fundamental nature of inertia, change is the only absolute phenomenon. Marxists acknowledge the realization that nothing is eternal, that everything is subject to change, has compelled the natural and social sciences to adopt an evolutionary approach to their subject matter. As Newton observed, nature delights in transformations too. In the introduction to his Dialectics of Nature, Engels gives an account of the revolutionary impact the acceptance of this basic fact had on the sciences in the 18th and 19th centuries. Let us, following Engels, make a brief survey of the history of some of the sciences. Cosmogony. In 1749, the French scholar, the Comte de Buffon, in his Encyclopédique Naturelle Histoire, suggested a theory of cosmic evolution without an act of divine creation, and was, therefore, forced by the opposition of the Church, to recant his views. But times changed, and the idea was hard to suppress. It was put forward again in 1755, in an anonymous pamphlet entitled A General History of Nature, published in Germany, in I-796, the French savant, Laplace, in his exposition of the system of the world, attempted to place the theory on a scientific basis. And when Napoleon inquired why the Creator was not even mentioned, Laplace is said to have replied that he had no need of that hypothesis. 6 eons ago, the universe was a mass of very high-temperature gas. From this there condensed rapidly spinning molten spheres, the stars. From one such star, our Sun, smaller drops were flung off to revolve round the mother sphere. These are the planets, the Earth among them. Change, then, is the basic theme of cosmogony after Laplace, not gradual change, but change with explosions, creation of planets, the airing up and burning out of the stars. The theory has been amplified, moded, challenged, contradicted, and superseded. However, since Laplace, it has been incontestable that the universe has a history of birth, growth, and decay. The old mythological concepts of a ready-made world, in which only regular seasonal variations occur, were shattered. Geology. Under scientific investigation, the Earth's crust yielded its story. The continents and oceans have not been eternal. The cooling of the Earth's crust has been uneven, land masses were suddenly elevated, continents forced to drift apart, mountain ranges were pushed up and new oceans formed. Huge ice sheets, then advancing, now retreating, covered the Earth's surface for millennia. The pioneer geologist, James Hutton of Scotland, in his theory of the Earth said quite aptly that he could see no trace of a beginning and no prospect of an end/7. Biology. In 1859 Charles Darwin published The Origin of Species, which not only provided convincing evidence for the earlier conjectures of the evolution of animals and plants, but also advanced new, revolutionary concepts of evolution. Through the ages, complex organisms have developed from the \LL microorganisms. Variation, specialization, and adaptation to environmental conditions produce the distinguishing characteristics of the species as we know them. Darwin's explanation of the mechanism of the process, by the principles of natural and sexual selection, the survival of the littlest in the struggle for existence, is now seen to be insufficient to account for the evolution of species and has been supplemented and moded by further investigation, discoveries, and theories. But, alter Darwin, the evolution of living beings has to be an accepted fact. Not only is there a geographical distribution of animals and plants, there has also been a slow, but uneven, development in time. LHC belief in the zity of species received a mortal blow. Anthropology. When the Europeans set out on their voyages of discovery, they found many lands populated by peoples with other customs and cultures, and at other levels of civilization. In 1861, Baghavan, with his study of mother right, pioneered TLTE study of the history of the family. In 1877, Morgan published his Ilkt and Society, providing clear evidence of the evolution of the family. Marx and Engels immediately appreciated the work of Morgan and developed a theory of the evolution of the family and studied the underlying social forces and the unfolding of family norms. 8. Listary society changes, but for the large part, imperceptibly, that few noticed the changes or cared. Conservative people at all times accepted history as a divinely inspired achievement of a perfect society, that is, the existing one. Wars and revolutions were viewed as unfortunate disturbances of the smooth functioning of normal social life. 18. Introduction to philosophy of Marxism. But to Marx, who discovered the laws of social change, wars and revolutions, and the perpetually erupting class struggle in peacetime were integral parts of the process of world history. He predicted that in the further development, a socialist society would replace the capitalist, and that the prehistory of human society would accordingly close with this social formation. 9. Alas, for the smugness of the philosophers of the status quo, scientific investigation showed that change had ravaged everything that they had considered XED and unchanging and handed down from time immemorial. And science, every branch of it, was forced to recognize the importance of the consideration of evolution, development, and change. We can agree, then, with Engels, that the world is not to be comprehended as a complex of ready-made things, but as a complex of processes, in which the apparently stable things, no less than their mind images in our heads, go through an uninterrupted process of coming into being and passing away, in which in spite of all seeming accidents and of all temporary retrogressions, a progressive development asserts itself 1 degree. Chapter 5. Some fundamental principles. It was Hegel who drew the distinction between dialectical thinking and metaphysical thinking. The following principles, inter alia, distinguish dialectical from metaphysical thought. L phenomena are studied in their contexts of space and time. An event, occurred, is a statement that is incomplete and, therefore, meaningless. The statement has meaning only when the place and time are specified. Every farmer knows that the success of his crop depends not only on the quality of his seed but also on the nature of the soil, and of course, the weather. Every child knows that wild plants differ, at least in size, from the same plants grown in pots. Charles Darwin, in 1876, confessed, "In my opinion, the greatest error which I have committed has been not allowing sufficient weight to the direct action of the environments." To the famous American plant developer, Luther Burbank, observed, "A fact is relative, and if it is placed out of its relative position, it apparently is not a fact, often." As early as 1842, Marx pointed out that, the correct theory must be made clear and developed within the concrete conditions and on the basis of the existing state of things. Criticizing Proudhon, Marx remarked that his history proceeds in the misty realm of imagination and rises far above space and time, and emphasized that all social forces are historical and transitory. 5. A Negro is a Negro, Marx pointed out, only in certain conditions does he become a slave. And again, hunger is hunger, but the hunger that is satisfied with cooked meat eaten with fork and knife is a different kind of hunger from the one that devours raw meat with the aid of hands, nails, and teeth. In 1877, Marx observed, "Thus events strikingly analogous but taking place in different historical conditions lead to totally different results." Commenting on the absolute truth of the utopian socialists, Engels wrote, "And as absolute truth is independent of time, space, and of the historical development of man, it is a mere accident when and where it was discovered." In criticizing Feuerbach's theory of morals, Engels commented, "It is designed to suit all periods, all peoples, and all conditions, and precisely for that reason it is never and nowhere applicable." Degree. The idea is already there in Hegel, who wrote, "Space and time are LLED with matter. Ust as there is no motion without matter, so there is no matter without motion." In sum, as Engels said, the basic forms of all being are space and time, and being out of time is just as gross an absurdity as being out of space. 2. In 1908, Lenin repeated, "There is nothing in the world but matter and motion, and matter in motion cannot move otherwise than in space and time." In the same year, Hermann Minkowski, who developed the mathematics of Einstein's theory of relativity, observed, "Nobody has ever noticed a place except at a time, or a time except at a place." Juxtaposing phenomena out of their contexts produces anachronisms or absurdities, a method that was probably exploited by Cervantes in his celebrated novel. Marx commented, "Don Quixote long ago paid the penalty for wrongly imagining that knight-errantry was compatible with all economic forms of society." 5. Mark Twain used the reverse technique to poke fun at evil England in his A Connecticut Yankee in King Arthur's Court h. 889. 2. Phenomena are studied in their interconnections with one another. Just as a phenomenon cannot be isolated from its context of space and time, one phenomenon cannot be isolated from another. Goethe once observed, "In nature we never see anything isolated, but everything in connection with something else which is before it, beside it, under it, and over it." Marx said that, "Circumstances make men as much as men make circumstances." And again, by acting on nature outside himself, man changes his own nature. In 1853, commenting on the events in China, Marx wrote, "The next uprising of the people of Europe may depend more probably on what is now passing in the Celestial Empire." Marx noted, "Interaction between the various aspects takes place in every organic unity." 32 degrees. Engels wrote, "The whole of nature accessible to us forms a system, an interconnected totality of bodies. They react on one another too." He emphasized, "Dialectics is the science of interconnections." 22. And again, reciprocal action is the thing that we encounter when we consider matter in motion. I'll pointed out, the essential element of life is the continual interchange with the natural environment. 2. Franz Mehring wrote, historical materialism is no closed system crowned with an ultimate truth, it is a scientific method for the investigation of human development. It begins with the indisputable fact that men live not only in nature, but also in society. There are no such things as isolated men. Every man, who by accident is left outside human society, quickly starves and dies. The history of any people is the history of its neighbors, observed the historian Rudolf Goldschmidt. Z. Engels in his introduction to Marx's class struggle in France commented on the irony of history in that Bismarck was instrumental in creating the German Empire and the French Republic. Trotsky advised revolutionaries to study the history of America and England together, because the United States and Great Britain must be regarded as twin stars, one of which grows dim the more rapidly as the brilliancy of the other increases. 27 We may add that the study of the history of England also necessitates the study of the history of her former empire, especially India. Scientific investigation has provided us with a number of vivid illustrations of this principle. Sir Isaac Newton taught us that all matter interacts gravitationally. There is interaction, even as the ancients knew, between electrical charges and also between magnetic poles. Erwin Schrödinger emphasized, physical action is always interaction, it always is mutual. p. 28 The work of Ørsted, Henry and Faraday in the early years of the last century established the laws of interaction of magnetic fields, electric currents and mechanical forces, and made possible the electric motor and the dynamo, which opened up vast new resources for mankind. In 1864, James Clerk Maxwell, by mathematical analysis of these interactions and a synthesis of the existing knowledge of electromagnetic phenomena, predicted the existence of a broad spectrum of electromagnetic waves of which visible light is only a small part. In 1888, Heinrich Hertz detected radio waves in a part of the non-visible spectrum and laid the foundation for a major breakthrough in communication. In 1895, Röntgen discovered X-rays in another part of the electromagnetic spectrum. The whole of chemistry is the study of the interaction of the elements and their compounds. Only a few elements like gold, sulfur, and carbon are found in their pure form. The inert gases went undetected for a long time, precisely because they do not interact with other elements. And it is a significant fact that the RST of them to be detected was observed by spectroscopy not on Earth but in the Sun, and aptly named helium * by Franklin and Lockyer. It was 1895 when helium was detected on Earth by the experimental ingenuity of William Ramsay. The other inert gases were tracked down in rapid succession. Rayleigh and Ramsay isolated argon in 1895, Ramsay and Travers isolated neon, krypton, and xenon in 1898, and Nally, in 1900, Ramsay and Dorn identified radium emanation, radon, the last of the inert gases. Despite their usefulness and importance in physics and industry, none of these gases has a chemistry. And when in 1896, Henry Becquerel discovered a phenomenon, which Madame Curie a short while later termed radioactivity, science found a door to enter the subatomic world. It was soon found that the fundamental characteristic of the elementary particles is that they interact, they attract, repel, fuse, annihilate each other, and sometimes split up or transform themselves. Three phenomena are studied in the process of their development. To ignore change, the ancients warned us, is to ignore nature. Centuries ago, Heraclitus taught us that to understand nature means to represent it as a process. A study of phenomena in the process of change is far more instructive and rewarding than a study of the static state. The history of geometry illustrates the value of a dynamical study of space. Plato, who encouraged the study of geometry, is said to have had inscribed at the entrance to his academy the words, "Let him not enter here who knows no geometry." In his overenthusiasm, however, he placed the study of the subject in a straitjacket by insisting that the unknelt instruments permissible were an unmarked straight edge and a pair of compasses. Euclid with brilliant logic systematized all the available knowledge of geometry in his monumental Elenaisms, but succeeded, as we see it today, in producing only a still life. Time, and the position of geometrical gears has no significance in his system. Archimedes, Apollonius, and their contemporaries tried to introduce time and movement into geometry, but, handicapped by a lack of a suitable number notation and mathematical symbolism, could not make much progress. Europe had to wait for centuries until the Arabs brought the Hindu number system and Arabic algebra and trigonometry to fertilize the mathematical knowledge of antiquity. The concept of movement in geometry was reintroduced by Bishop Orsma, and 2 millennia after Euclid, René Descartes published his La Géométrie, in which he fused 2 streams of mathematics and applied algebraic methods to geometrical problems, and geometrical methods to algebraic problems. Marx accepted this principle even while a student. In 1837 he wrote to his father, "The object itself must be studied in its development." 3. In his afterword to the second edition of Capital, Marx made a very important observation: of course, the method of presentation must differ from that of inquiry. The latter must appropriate the material in detail, to analyze its different forms of development, to trace out their inner connection. Only after this work is done, can the actual movement be adequately described. If this is done successfully, if the life of the subject matter is ideally rected as in a mirror, then it may appear as if we had before us a mere a priori construction. 32 Engels warned us that the world is not to be comprehended as a complex of ready-made things but as a complex of processes. 33 Dialectics, Engels said, grasps things and their images, ideas, essentially in their interconnections, in their sequence, their movement, their birth and death. 34 Trotsky commented, Marxist thought is dialectical, it considers all phenomena in their development, in their transition from one state to another. 35 And again, Marx's method is dialectical, because it regards both nature and society as they evolve, and evolution itself as the constant struggle of connecting forces. 3 degrees In his last polemic against the opponents of dialectics, Trotsky observed, vulgar thought operates with such concepts as capitalism, morals, freedom, workers' state, etc., as XED abstractions, presuming that capitalism is equal to capitalism, morals are equal to morals, etc. Dialectical materialism analyses all things and phenomena in their continuous change, while determining in the material conditions of those changes that critical limit beyond which A ceases to be a worker's state ceases to be a worker's state. The fundamental awe of vulgar thought lies in the fact that it wishes to content itself with motionless imprints of a reality which consists of eternal motion. Dialectical thinking gives to concepts, by means of closer approximations, corrections, concretizations, a richness of content and exibility, I would even say a succulence which to a certain extent brings them closer to living phenomena. Not capitalism in general, but a given capitalism in a given state of development. Not a worker's state in general, but a given worker's state in a backward country in an imperialist encirclement, etc. Dialectical thinking is related to vulgar thinking in the same way that a motion picture is related to a still photograph. The motion picture does not outlaw the still photograph but combines a series of them according to the laws of motion. T37. 4 Dialectics studies particular aspects of a phenomenon without losing sight of its generality. It analyzes and synthesizes. It is proverbial, that the whole is more than the mere sum of its parts. An animal or plant is more than a mere collection or arrangement of cells. 38. A poem is more than a collection of words. A painting is more than a collection of pigments. 39. Society is more than a collection of individuals. The world economy is not a mere sum of national economies. Examples may be continued without end. Professor Kaffa said, rather forcefully, that the whole is something other than the sum of its parts. There is a lot of dialectical wisdom in the ancient tale of the blind men who sought to perceive the shape of an elephant by feeling the part nearest each of them. Unable to synthesize their observations, they fell out among themselves. 1. Scientific investigation has scored great successes by using the method of analysis, abstraction, and isolation, by studying certain aspects of a phenomenon, while eliminating all else that is, for the immediate purpose, irrelevant. In his discourse on method, René Descartes advised us to divide each of the difficulties under examination into as many parts as possible, and to proceed always from the simplest and easiest to the more complex. 3. Si. Vavilov observed in his study of Isaac Newton, many stages in the history of science have been accompanied by an intentional disregard temporarily, of a group of facts and whole spheres of phenomena that complicate a problem. In 1583, Galileo Galilei, then only 19 years old, while gazing at an ornate chandelier swinging gently during a service in the Cathedral of Pisa, saw in the complex system just three things: the point of suspension, the length of the system, and the weight attached to the end of it. This was, in essence, a plumb line, an instrument known from ancient times. It required the genius of Galileo, timing the swings by his pole speed, to see in an oscillating plumb line the dynamical proportions of the pendulum. By this process of abstraction he was able to discover the principle of regular oscillations, a discovery which provided a theory for accurate mechanical timekeeping and laid the foundation for a new era in the history of man. Though the breaking up of a complex system into simpler parts helps the study of a phenomenon, it is by no means all there is to the study of the original complexity. In his Revolutions, Copernicus warned us, the scientist who would examine the various phenomena individually, without regard to the order and close dependency among them, might be compared with a man who would borrow fragments, such as hands, feet, and other parts of the body, which, though truly painted by a master's hand, represent different bodies, and who would attempt now to put these heteroclitic fragments together, which do not tie one to the other, and the composition of which would rather yield the picture of a monster than that of a human body. Hegel pointed out the same, only in their connection are the individual limbs of the body what they are. A hand, separated from the body, is a hand only in name. Engels wrote, in order to understand the separate phenomena, we have to tear them out of the general interconnection and consider them in isolation, and then the changing motions appear one as the cause and the other as effect. 7. Lenin observed, the splitting of a single whole and the cognition of its contradictory parts is the essence of dialectics, and again, that one of the elements of dialectics is the union of analysis and synthesis. Dialectics studies the all-sidedness, the complexity of a phenomenon, the richness of its content. It sees variety in the generality and generality in the variety. Analyses and syntheses. 5. Conceptual totality must be distinguished from concrete totality. In an unused draft, Marx left us a section entitled On the Method of Political Economy, in which he pointed out that political economy, like the other sciences, starts out by analysis and reconstructs a scientific system by synthesis. The latter is obviously the correct method. The concrete concept is concrete because it is a system of many definitions, thus representing the unity of diverse aspects. He drew the very important distinction between concrete totality and conceptual totality. 9. The Oxford mathematician, the Rev. Charles Dodgson, writing under the pseudonym Lewis Carroll, has left us a picturesque description of a concept in Alice in Wonderland. In Chapter I, Alice tried to fancy what the aim of a candle looks like after the candle is blown out, for she could not remember ever having seen such a thing. And still more graphically in Chapter 6, the Cheshire Cat vanished quite slowly, beginning with the end of the tail, and ending with the grin, which remained some time after the rest of it had gone. The classic case of a conceptual system, one which was unchallenged for more than 2 millennia, is that of Euclidean geometry. Euclid, following his predecessors, beginning with Thales, used a set of abstractions: non-dimensional points, unidimensional lines, two-dimensional planes, and three-dimensional space, to give us in his Elements a grand conceptual system of geometry. In other fields of science, the creation of conceptual systems proved to be more complicated. In 1846, Michael Faraday wrote to a friend, "The view which I am so bold as to put forth endeavors to dismiss the ether, but not the vibrations." 5. Ames Clerk Maxwell, in his inaugural lecture as Cavendish professor, complained, Wrenching the mind away from the symbols to the objects and back from the objects to the symbols, that is the price we have to pay. 52 Maxwell scored great successes in theoretical physics, but did not succeed in dismissing the ether. As is well known, the ether concept was dismissed only in 1905, after Einstein's theory of relativity. Writing in recent times, the great naturalist Darcy W. Thompson advised biologists to learn from the mathematicians to eliminate and to discard, to keep the type in mind and leave the single case, with all its accidents alone. Why 5. 6. The results of an investigation depend on the standpoint of the investigator. It is common experience that warm feels cold if one's hand has earlier been immersed in hot water, and that cold water feels warm if one's hand has earlier been in iced water. The sun rises in the east and sets in the west, is an observation true enough in the tropic and temperate zones. However, in the Arctic and Antarctic circles, for some months the sun never sets and for other months it never rises. For the pioneer explorers who sailed south down the west coast of Africa, the sun rose on the left. The day it rose from the right, they realized that they had rounded a cape. Raindrops which are seen to fall vertically by an observer at rest, appear to slant towards a moving observer. Let us view, with Einstein, the fall of a stone from a moving train. If we are in the train, the stone appears to fall vertically downwards. But from the embankment the stone is seen to move in a curve produced by the effect of two motions, the forward motion of the train and the downward motion to Earth. LL is a basic idea of Einstein's theory of relativity that all measurements are made, not in the abstract absolute, but in a given real framework of space and time. The Doppler effect, as an acoustic phenomenon, will be familiar to all keen observers. The pitch of a note drops as the source of the sound, a whistling train or a whining jet, approaches, passes and recedes. Doppler RST predicted the effects, in I-842, for optical phenomena. If the source of light is moving away from us, the spectrum shifts to the red end, if towards us, to the blue end. The observations of this effect led to Hubble's theory of an expanding universe 5. Let us now go back to a classic case. To an observer on Earth, the sun, moon, planets, and the stars appear to move round the Earth. This geocentric system, associated with the name of Ptolemy, led to complications in the calculation of planetary orbits. Anyone who has tried to unravel the mysteries of ancient and medieval astronomy can appreciate the irreverent remark attributed to King Alfonso of Castile, that had he been present at the creation, he would have suggested something simpler. Copernicus separated the daily rotations of the Earth on its axis and the annual revolutions round the Sun. He shifted the axis of the solar system from the Earth to the Sun and thus not only provided an explanation of the observed retrograde motion of the outer planets *, but, more important, he discovered the sixth planet, our own Earth. His revolutions gave astronomy, and mankind, a new perspective and laid the foundations for the later work of Galileo, Kepler, and Newton. It marked, as Engels noted, natural science's declaration of independence from theology. 57 Marx explained that his standpoint was one from which the evolution of the economic formation of society is viewed as a process of natural history. 58 Marxists view history from the standpoint of the interests of humanity, that is, of the revolutionary establishment of a socialist society. Lenin emphasized that, there can be no impartial social science in a society based on class struggle. It was this standpoint and perspective which enabled Marx and Engels to see far into the 20th century. As Rosa Luxemburg observed, their prophetic eyes saw events as they lay in the womb of the future. Degree assuredly, wrote Trotsky of the Communist Manifesto, the young authors were able to look further the future than anyone before them, and perhaps anyone since them. If they were over-optimistic as to the tempo of revolutionary events, that was because they stood on a high mountain, and distances seemed shorter to them. Degree 2. 7 Scientific laws and theories are limited to India. Westward sea route to India. For more accurate purposes, jet flight and rocketry, we have to make allowances for the fact that the Earth is an oblate spheroid, bulging a little at the equator and a little at the poles. This fact was predicted, theoretically, by Newton, proved experimentally by Huygens, and recorded by survey by the French after the Revolution. With the realization that the Earth is spherical, up and down lose their absolute meaning, and the vertical, determined by a plumb line or the direction of a falling body, becomes limited to a local truth. The old saying, "What goes up must come down," was true in practice only till the 4th of October 1957, on which day a rocket leaving the Earth at a velocity of about 8 km/s put into orbit the RST artificial Earth satellite, the Sputnik. The Aristotelian maxim that nature abhors a vacuum, which was used to explain the action of water pumps, is true, as Galileo acidly observed, only to a height of 34 feet of water. The Euclidean lemma that the shortest distance between 2 points is a straight line, is true only for a plane surface. On a spherical surface, it is the arc of a great circle. In 1639, 2 years after the mathematical revolution of René Descartes, another Frenchman, Gerard Desargues, wrote a projective geometry. Basing himself on the eye-view requirements of painters and map makers, he introduced non-Euclidean concepts of parallel lines meeting at infinity, etc. But habits of thought die hard, even in abstract subjects like geometry. Desargues was ignored, all his books were lost, and his ideas came into their own only 200 years later from a manuscript copy made by one of his contemporaries. Euclid's fifth postulate, that through a point only one straight line can be drawn parallel to another, was challenged by Bolyai of Hungary, Lobachevsky of Russia, and the Germans Gauss and Riemann. They created new conceptual systems of geometry without this axiom, and opened up new perspectives in geometry and physics. Zeldovich has aptly described their work as the lightning lashes that preceded the thunderbolt of Einstein's theory of relativity. In the early years of this century, it was found that Euclidean geometry was inadequate to describe the physical space required by Einstein's theory of relativity, and, in 1908, Hermann Minkowski had to revive the concepts of non-Euclidean space and introduce a four-dimensional space-time continuum. Some scientists sighed nostalgically, that Euclid has been so psychologically satisfactory. In another field of investigation, statistics, Willard Gibbs of America found that he had to use the concept of hyperspace. From a study of nature, Darcy W. Thompson makes an interesting remark that the bee's world may be four-dimensional. 7 As Steinmetz has observed, all mathematical truths are relative truths. 72 Perhaps the RST mathematician who drew attention to this fact, Archbishop Nicholas Cusanus, who, in the 15th century, pointed out that rules for finite quantities are invalid for infinites, and, as we may note by extension, for infinitesimals. 7 In Anti-Düring, Engels draws attention to the fact that Boyle's law had a limited range of validity. In his Dialectics of Nature, he points out that as there is no water on the sun or moon, the law of the boiling of water is merely local, historical, and not eternal. Descartes, who, in the 19th century, unwittingly laid the foundation for French materialism, gave us a picture of the animal as a machine. La Mettrie took the idea to its logical conclusion in his anonymous Man Mach Irie. In the 40s of the L9th century, the reductionists of the Helmholtz school were determined to establish that the physiology of organisms is, ultimately, the action of physical and chemical forces. They were opposed by the vitalists of the Liebig school, who maintained that the life sciences required an extra, vital, force. The synthesis of urea, an organic substance from inorganic matter, by Wohler in 1828 should have settled the question, but the controversy continued to rage through the 19th century, and we end that as late as 1861 the great Mendeleev had to enter the lists on the side of the reductionists. In Organic Nature, Engels wrote, "The laws of mechanics are, indeed, also valid, but are pushed into the background by other, higher laws. 8 Physiology is, of course, the physics and especially the chemistry of the living body, but with that it ceases to be specially chemistry. On the one hand its domain becomes restricted, but, on the other hand, inside this domain it becomes raised to a higher power. 82 In recent years the biochemist Joseph Needham concluded after experimental study that organic nature follows not physico-chemical laws but congruent laws on a higher plane. 8. Hegel was emphatic, if the truth be abstract, it must be untrue. Philosophy is what is most antagonistic to abstraction, it leads back to the concrete. 85 Marx and Engels never tired of repeating, after Hegel, that the truth is concrete. In the Communist Manifesto they criticized bourgeois theorists. The self misconception that induces you to transform into eternal laws of nature and of reason, the social forms springing from your present mode of production and forms of property, historical relations that arise and disappear in the progress of production, this misconception you share with every ruling class that has preceded you. As a Russian reviewer of Capital correctly pointed out, in his L. Marx's opinion every historical period has laws peculiar to itself. Soon as life has gone through a given period of development and is passing over from one given stage to another, it begins also to be controlled by other laws. 87 When Mikhailovsky described Marx's historical materialism as a suprahistorical principle, Marx protested. He is honoring me and shaming me too much. And declared that there were no historico-philosophical master keys. Marx also denied that there was an abstract law of population. Every stage of development has its own law of population. Historically valid within its limits alone. 89 When attempts were made to explain human history as a continuation of the Darwinian struggle for existence in animal evolution, Engels objected, the most that the animal can achieve is to collect, man produces, he prepares the means of life in the widest sense of the words, which, without him, nature would never have produced. This makes impossible the immediate transference of the laws of life in animal societies to human ones. 9 In 1865, Engels pointed out, to us, so-called economic laws are not eternal laws of nature, but historical laws which arise and disappear. 91 In Anti-Düring he wrote, political economy cannot be the same for all countries and for all historical epochs. Political economy is essentially a historical science. It deals with material which is historical, that is, continually changing. 92 Trotsky observed, it was not Marx's aim to discover the eternal laws of economy. He denied the existence of such laws. The history of the development of human society is the history of the succession of various systems of economy, each operating in accordance with its own laws. 3. To illustrate that each law has only a limited range of validity, Plekhanov gave a graphic example, consider a man eating bread. The laws that work on the bread once it is in the stomach are the laws of digestion, but the laws that determine it with he man eats bread and not cake, are the laws of economics. Dialectics rejects all concepts of eternal and abstract truth. Lenin repeated after Hegel and Marx, the fundamental thesis of dialectics is, there is no such thing as abstract truth, truth is always concrete. 95. Before we pass on, let us make brief mention of a profound idea Niels Bohr put forward in 1922 as his correspondence principle. He pointed out that the new laws of physics should carry the classical laws on the face of them, the equations of relativity should reduce to classical form if the velocity of the body is very small compared to the velocity of light. Quantum laws likewise should become classical if Planck's constant h is set to 0 *. In the words of Einstein and Infeld, the new theory shows the merits as well as the limitations of the old theory and allows us to regain our concepts from a higher level. 9. A similar train of thought is to be found in one of Marx's Unished drafts of 1857-8, the anatomy of man is a key to the anatomy of the ape. On the other hand, rudiments of more advanced forms in the lower species of animals can only be understood when the more advanced forms are already known. Bourgeois economy thus provides a key to the economy of antiquity. 97. Chapter 6. The unity of opposites. Metaphysical thinking divides phenomena into immutable opposites, good and bad, love and hate, life and death, truth and error, and so on. Dialectics, on the other hand, recognizes not merely the coexistence, but the unity of opposites, their interpenetration, interaction, their transformation, one into the other. Marx, referring to Hegel, wrote, "A most profound yet fantastic speculator on the principles which govern the movements of humanity was wont to extol as one of the ruling secrets of nature what he called the law of contact of extremes. The timely proverb that extremes meet was, in his view, a grand and potent truth in every sphere of life, an axiom with which the philosopher could as little dispense as the astronomer with the laws of Kepler or the great discovery of Newton." Engels noted, "The dialectics that has found its way into popular consciousness is expressed in the old saying that extremes meet too. Good and bad daily experience teaches us that a person can be good at one time, bad at another. No one can really be classified as permanently good or permanently bad, or placed in any other XED category." The French poet Baudelaire observed, "In every man there are two simultaneous aspirants, one for God and one for Satan." Leo Tolstoy expressed this fact very forcefully. One of the most widespread superstitions is that every man has some distinguishing quality, one is kind, another cruel, a third wise or stupid, or energetic, or apathetic. Men are not really like that. We may say of a man that he is more often kind than cruel, more often wise than stupid, more often energetic than apathetic, or the reverse, but it would not be true to say of one man that he is kind and wise, of another that he is bad and stupid. And yet we always classify mankind in this way. And this is false. Men are like rivers, the water is the same in one and all, but every river is narrower, more rapid there, here slower, there broader, now clear, now dull, now cold, now warm. It is the same with men. Every man bears in himself germs of every human quality, but sometimes one quality manifests itself, sometimes another, and the man often becomes unlike himself, while still remaining the same man. Love and hate. In the eld of human psychology, love and hate are not merely opposite, but coexistent and interpenetrating emotions. The ancients were aware of this. Empedocles of Acragas, Sicily, in the 5th century BC taught that love and hate move the world. *5 Literary genius realized this fact intuitively. Shakespeare in his sonnets sang, "Past reason hunted, and no sooner had, past reason hated." He made Juliet confess, "My only love sprung from my only hate." 6 Leo Tolstoy made a deep psychological observation: a period of love, a period of hate, a weak period of love, a brief period of hate, an intense period of love, a prolonged period of hate. We did not then realize that this love and hate were different aspects of one and the same animal feeling. The interplay of opposite emotions dominates the craggy literary monuments left to us by Fyodor Dostoevsky, himself described by a biographer as a man of re and ice. 3. In her touching memoirs, Marx's daughter Eleanor said her father could hate so earnestly only because he could love so profoundly much of the work of D.2. Lawrence contains this love-hate theme. In his Sons and Lovers we nd, something in him hated her again for submitting him to this torture of nearness. And he loved her. 9 In his Rainbow he speaks of a heart hard with tenderness, and again, so it went on continually, the recurrence of love and connect between them. One day it seemed as if everything was shattered, all life spoiled, ruined, desolate, and laid waste. The next day it was all marvelous again, just marvelous. One day she thought she would go mad from his very presence, the sound of his drinking was detestable to her. The next day she loved and rejoiced in the way he crossed the Our, he was sun, moon, and stars in one. Sigmund Freud, in 1882, long before his scientific study of the psyche, observed in a letter to his aunt she, "Only in logic are contradictions unable to coexist, in feelings they quite happily continue alongside each other." The term ambivalence, which was coined by Eugen Bleuler to describe the phenomenon, was immediately adopted by Irid. In his Clark University lectures, he noted that instincts occur in pairs of opposites. In 1937, he wrote, the circumstances that many instincts are manifested almost from the RST in pairs of opposites, a very remarkable phenomenon and one strange to the lay public, which is termed the ambivalence of feeling. Psychoanalysis adds that the connecting feelings not infrequently have the same person for their object. 15. In his last, unused work, An Outline of Psychoanabasis, Freud, acknowledging the philosophical intuition of Empedocles, wrote, "This interaction of the two basic instincts with and against each other gives rise to the whole variegation of the phenomena of life. The analogy of our two basic instincts extends from the region of animate things to the pair of opposing forces, attraction and repulsion, which rule the inorganic world." Degree. These were not incidental observations, but statements of one of the basic principles of psychoanalysis. Freud has been accused of obstinate dualism, and of a very characteristic kind of dialectical thinking that tends to base theories on the interaction of two opposite powers of having, a difficulty in contemplating any topic unless he could divide it into two opposites. 17. Pleasure and pain. The intimate connection between pleasure and pain was long recognized by the ancients. While this is not quite RSL.LBB cone seldom we hear, pleasure is nothing else but the intermission of pain. From John Dryden. Sweet is pleasure after pain. And from William Congreve, I love to give pain. Heinrich Heine sang of ravishing torture and blissful pain, terror and ecstasy. In Heine's poetry, as also in his life, love and pain are equivalent. Guy de Maupassant, in his Olive Orchard, wrote of the perverse charm of a smile, hateful but caressing. Pleasure in enacting pain and pleasure in suffering it are two complementary manifestations, difficult to distinguish or separate. Havelock Ellis, in his exploration of this most difficult, most fundamental problem, quotes the physiologist Burdake, who recognized that it is precisely the alliance of pleasure and pain which constitutes the voluptuous sensation. He also notes that the biological conditions of courtship impose an aggressive as well as a submissive role to the male. He concludes that between sadism and masochism, there is no real line of demarcation. They cannot, therefore, be regarded as opposite manifestations. Later writers have referred to these phenomena by the compound term sadomasochism. Sigmund Freud noted, it has also been claimed that every pain contains in itself the possibility of a pleasurable sensation. 2. And that sadism and masochism are the most important representatives of the pairs of opposite instincts. 22. In his Beyond the Pleasure principle, Freud gave the study of these phenomena a new dimension, a depth lacking in the earlier literature. Here, he speaks of the pleasure-pain principle. It is worthwhile, in this connection, to recall Havelock Ellis' assessment, everything Freud has touched, that indeed is always a mark of genigtas, takes on a new significance and becomes of importance. Why? Life and death. Man has long recognized, intuitively, that life and death are not distinct, but interconnected phenomena. In many mythologies the gods are not only creators, but also destroyers. It is now common scientific knowledge that the process of life, metabolism, consists of the process of growth, anabolism, and the process of decay, catabolism. Under normal conditions, in youth, the forces of growth have the better of the forces of death. In adulthood, the forces equalize, living tissues replace the dead, while all perceptible growth ceases. As old age sets in, the forces of death begin to predominate and nally the organism ceases to live. In Claude Bernard's apt definition, life is the ensemble of functions that resist death. To life and death are interrelated phenomena, the result of forces in constant conflict. While it was Hegel who drew attention to the philosophical importance of this fact, his contemporary Goethe said it in poetry. Birth and the Grave, an Eternal Sea. 25. Engels pointed out that, life is also a contradiction which is present in things and processes themselves, and which constantly asserts and solves itself, and as soon as the contradiction ceases, life, too, comes to an end. 2 degrees concisely, living means dying. Quite early in his work, in 1910, Freud discovered the motivations of suicide, self-capital punishment, The unconscious forces of self-destruction become stronger, for a moment, than those of self-preservation. However, it is a point, if unsuccessful, that may never be repeated in a lifetime. In later years, in working out a theory of instincts, he proposed the concept of a death instinct as opposed to a life instinct. Eros, he claimed, was always opposed by then eidos. Hegel's formulation. In his logic, Hegel stressed the unity of opposites. Positive and negative are supposed to express an absolute difference. The two, however, are at bottom the same. The name of either might be transformed to the other. Thus, for example, debts and assets are not two particular, self-subsisting species of property. What is negative to the debtor is positive to the creditor. A way to the east is also a way to the west. Positive and negative are therefore intrinsically conditioned by one another, and exist only in relation to each other. The north pole of a magnet cannot be without the south pole and vice versa. If we cut a magnet in two, we have not a north pole in one piece and a south pole in the other. Similarly, in electricity, the positive and negative are not two diverse and independent fluids. In opposition, the difference is not confronted by any other, but by its other. 3 degrees. Let us add to Hegel's series of examples, Newton's exact formulation of the unity of opposites for mechanical forces, the well-known third law of motion. To every action there is always opposed an equal and opposite reaction. This fundamental law was already implicit in Archimedes' law of flotation, historically one of the RST laws of physics. The weight of a body floating in a fluid is offset by the upthrust of the weight of the fluid displaced. Ti. The idea can be traced back to the 6th century BC. Anaximander, the second Western philosopher, was the RST to conceive of abstract oppositions, wet-dry, hot-cold, balancing each other. In the next century, Heraclitus announced his doctrine of opposite tensions. Opposites interact. The coexistence of opposites is not a static state. Opposites interact, there is attraction and repulsion. To quote Sir Isaac Newton, I am inclined by many reasons to suspect that they may all depend upon certain forces by which the particles of bodies, by some causes hitherto unknown, are either mutually impelled towards each other, and cohere in regular gers, or are repelled and recede from each other. 1. The attraction and repulsion of magnetic poles was known from ancient times, so was electrostatic attraction. Electrostatic repulsion was RST observed by Otto von Guericke. Engels observed, where there is attraction, it must be complemented by repulsion. Hence Hegel was right in saying that the essence of matter is attraction and repulsion. Newton gave us his universal law of gravitation, an attractive force between all material bodies. If this were the only force, the universe would have packed up long ago. To explain the expanding universe, Einstein for a time, 1917 to 1931, used the postulate of the cosmological constant, which was counterposed as a universal repulsive force. Physicists tell us that within the molecule there are attractive as well as repulsive forces, which, between them, assure molecular stability. Perhaps the RST intellectual crisis in the history of man was that of the Pythagoreans in the 5th century BC. In using counting numbers for the purpose of measurement, they came across some numbers like the square root of 2, which, while representing a finite measurement, could not be expressed as a ratio of two integers. They probably did not want to divulge their problem, and such numbers they called illegon. We name them irrational, non-ratio, as opposed to rational numbers. The crisis was solved geometrically by Eudoxus in Greek times, and analytically only in the 19th century, when irrationals found their place along with the rationals on Euler's real number 1 numbers, positive and negative. Diophantus of Theon, the last great Awangabraist of antiquity, was able to recognize negative numbers, but rejected them as absurd and impossible, and for 1,000 years European mathematicians failed to explore the interesting and vital world of the negative. The Chinese were probably the RST to use negative numbers, and we know that in 7th century India, Brahmagupta used negatives in his calculations. In the 13th century, Fibonacci conceded that negative numbers could express debts. By the end of the 16th century, negative numbers became respectable. In 1629, the Frenchman Girard showed how to depict them geometrically. However, even Descartes called them false numbers. 37 It was only in 1659 that Hud used variables which could be negative as well as positive, and thus opened up the negative domain to mathematical investigation. Numbers real and imaginary. Diophantus also gave us the rule of signs asterisk, according to which no signed number multiplied by itself could be negative. The concept of the square root of a negative number, RST, used by Cardinal in 1545, was described by Napier as a ghost number 39, and as late as 1702 by Leibniz as an wonderful invention of a marvelous mind, almost an amphibian between things that are and things that are not. Degree Descartes called them imaginaries, a name that is still used. Euler symbolized the impossible square root of -1 by the letter I. However, he too maintained that such numbers were necessarily imaginary or impossible. Wessel of Norway and Argand of Switzerland showed that complex numbers could be photographed, that is, represented graphically. Gauss was convinced that just as objective an existence can be assigned to imaginary as to negative quantities. 3. By the early 19th century, complex numbers had found their useful and important function in mathematics, physics, and engineering, and when we advance a little in mathematics, we will be compelled to agree with Hadamard's interesting observation that the shortest path between two truths in the real domain passes through the complex domain. 4. In 1821, Cauchy pointed out that the complex roots of an equation occur in opposite pairs, i.e., if is a root, so also is, and that in calculations I is equivalent to plus I, though, being reciprocals, they are not identical. Before passing on, let us consider the following simple-looking equations: x1 equals 0, 2x1 equals 0, x plus 1 equals 0, x2-2 equals 0, x2 plus 1 equals 0. The solution of the RST is x equals 1, a whole number, of the second is x equals 1/2, a fraction, of the third is x equals -1, a negative number, of the fourth is the square root of 2, an irrational number, and of the FTH is x equals 1, an imaginary number. Between the successful solutions of the RST and FTH equations lies a period of about 2000 years. The operations of mathematics. Let us note with the ancients that the 6 operations of arithmetic are extensions of the fundamental. Involution is extended multiplication, as multiplication is an extension of addition, so also, evolution is extended division, and division is an extension of subtraction. These operations can be grouped in 3 pairs of opposite processes: addition and its inverse subtraction, multiplication and its inverse division, involution and its inverse evolution. Once the concept of negative is introduced, subtraction becomes identical with addition. Change the sign and add, introduce the concept of reciprocals, and division is multiplication by the reciprocal of the divisor. Introduce fractional exponents, and evolution is the same as involution. The work of Napier and others not only gave us compact computational methods, the familiar operations of ending logarithms and anti-logarithms, but also made the unity of arithmetical operations obvious. Multiplication is performed by the addition of logarithms, division by subtraction, etc. In the calculus of Newton and Leibniz we have another pair of opposite operations, differentiation and integration, in the more expressive and appropriate terminology of recent textbooks, ending the derivative, and the antiderivative of functions. Finite process and finite results. There is a paradox, the Greek dichotomy, having, which was known at least as far back as Euclid's time. /6 Take a line segment and bisect it, then bisect the remaining half, then the remaining quarter, and so on. This is a process that can be carried on indefinitely, for the line segment itself will never be exhausted. Translated into arithmetic and modern notation, we have the inite series, 1/2 plus /4 plus /8 plus 1/16 plus 1 /az plus. The sum of which approaches but cannot exceed or even equal unity. In the language of Newton and Leibniz, unity is the limit of this innate series. The concept of limits was investigated in the 18th and 19th centuries and is now fundamental in mathematics. Not only do some innate series have innate sums, some innate quantities can be expanded and represented by an innate series. Engels noted, to common sense it appears an absurdity to resolve a d-innate magnitude, example a binomial expression, into an innate series, that is, into something infinite. X48 Erwin Schrödinger has pointed out that in the case of Greek science the idea of the innate is scarcely understood. The concept of the limitless process frightened the Greeks, as is evidenced in the well-known paradox of Achilles and the tortoise. It is no wonder that it took over 2,000 years from Euclid through Newton to able for the binomial theorem to be fully worked out. 5 degree As a special case of the binomial theorem we have the expansion of which as an innate series has a innate sum, which Euler baptized with the symbol E. Many mathematical roads are mapped out by E. It is ubiquitous and enters into the analysis of a whole range of phenomena, from organic growth to radioactive decay. Existence and non-existence. Can non-existence exist? To the question posed in this paradoxical form, Parmenides of Elea gave the ready answer, no. This was for those times, and also for ours, not a mere play on words. It was a philosophical question, and we may also suspect, a political question. Parmenides denied that change takes place and repudiated the method of observations. In doing so he was rejecting the teachings of the Pythagorean school. 5 The correct and profound answer came from Parmenides' contemporary, Heraclitus of Ephesus, with whom, according to Hegel, dialectics began. Heraclitus taught that all things flow. 53, everything is becoming. 5, existence and non-existence are meaningless in a changing world, everything is becoming. F55 Hegel readily adopted this view. Existence is in part mere appearance, and only in part reality. 5 degree Neither in heaven nor on earth is there anything not containing both being and n0 thing. 57. Pure being and pure nothing are the same. Their union is becoming. F58 Beginning contains both nix and sen, it is their unity. And again, that which is beginning, as yet is not, it is merely advancing towards being. Why on the ancient philosopher's intuition, Hegel commented, the recognition of this fact that being and not being are only abstractions devoid of truth, that the RST is to be found only in becoming, forms a great advance. Engels wrote, nature does not just exist, but comes into being and passes away. 1. And paid tribute to Heraclitus, this primitive, naive, yet intrinsically correct conception of the world was that of ancient Greek philosophy, and was RST clearly formulated by Heraclitus, everything is and also is not, for everything is in ux, is constantly changing, constantly coming into being and passing away. 2. Continuity and discontinuity, space and time. Zeno of Elea, a follower of Parmenides, in the 5th century BC posed 4 paradoxes, the most famous of which is that of the race between Achilles and the tortoise. Achilles, who, let us say, was able to run 10 times as fast as the unity of opposites. 5-1 Tortoise, had a 100-yard handicap. When Achilles covered the 100 yards, the tortoise was 10 yards ahead. Achilles then covered the 10 yards and the tortoise was 1 yard ahead. When the yard was covered, the tortoise was 1/10 of a yard ahead. Achilles could never overtake the tortoise. Achilles pleaded, let me overstep the limits degree, but then the Greeks, save for Archimedes, had no inkling of the concept of limits, and Achilles was left kicking his heels for 2 millennia, until the Renaissance and the work of René Descartes and the introduction of time into geometry in his time. Aristotle pointed out that space and time were innately divisible but not innately divided. Time cannot be divided into a series of individual nows. 7. Motion is not a sum of states of rest. Rather is rest a special case of motion. Centuries later, James Clerk Maxwell commented, up to Zeno's time, time was regarded as made up of a finite number of moments while space was confessed to be divisible without limit. Degree 9 *. Another of Zeno's paradoxes is said to have been posed at an archery contest. Indicating an arrow in it, he had said, either the arrow is there, or, it is not there. It cannot be not there. Therefore, it is there, and does not move. Motion was, thus, logically refuted. Actually, Zeno only demonstrated the inadequacy of the formal logic of the period. Heraclitus, as we have seen, gave us the solution. There is no existence or non-existence, there is only becoming. Zeno's arrow has not only the capacity of being there, but also the ability of being not there, that is, of moving. In explanation of the paradox, Hegel wrote, if we speak of motion in general, we say that the body is in one place and then it goes to another, because it moves. It is no longer in the rst, but not yet in the second. Were it in either, it would be at rest. If we say that it is between both, that is to say nothing at all, for were it between both, it would be in a place, and this would present the same difficulty. But movement means to be in this place and not to be in it. This is the continuity of space and time, and it is this which rst makes motion possible. 7 He added, what makes the difficulty is always thought alone, since it keeps apart the moments of an object which in their separation are really united. 7 On this question Engels wrote, so long as we consider things as static and lifeless, each one by itself, alongside of and after each other, it is true that we do not run up against any contradiction in them. We nd certain qualities which are partly common to, partly diverse from, and even contradictory to each other, but which in this case are distributed among different objects and therefore contain no contradiction. Within the limits of this sphere of thought we can get along on the basis of the usual metaphysical mode of thought. But the position is quite different as soon as we consider things in their motion, change, their life, their reciprocal unions on one another. Then we immediately became involved in contradictions. Motion itself is a contradiction. Even simple mechanical change of place can only come about through a body at one and the same moment of time being both in one place and in another place, being in one and the same place and also not in it. And the continuous assertion and the simultaneous solution of this contradiction is precisely what motion is. 73 Plekhanov commented, the movement of matter underlies all the phenomena of nature. But what is movement? It is an obvious contradiction. Should anyone ask you whether a body in motion is at a particular spot at a particular time, you will be unable, with the best will in the world, to answer in accordance with the formula, yes is yes, and no is no. A body in motion is at a given point, and at the same time it is not there. We can only consider it in accordance with the formula, yes is no, and no is yes. This moving body thus presents itself as an irrefutable argument in favor of the logic of contradiction, and one who is unwilling to accept this logic will be forced to proclaim with Zeno, that motion is merely an illusion of the senses. 7 The problem of the logical representation of motion is not a mere play on words. It is the central question of dialectics and has been with us since Zeno. Modern theoretical physics was compelled, not accidentally, to explore the problem again, and in 1927, Werner Heisenberg gave us his celebrated uncertainty principle, which we mention without discussion. Louis de Broglie summed up the problem from the physicist's point of view. Exact localization in time and space is a sort of idealization which excluded all evolution and all dynamism. The idea of a state of motion taken in all its purity is on the contrary a dynamic idealization contradictory in principle with the concepts of position and instant. 75 Motion presents the basic example of the unit of opposites. As Lenin noted in 1915, we cannot imagine, express, measure, depict movement, without interrupting continuity, without simplifying, coarsening, dismembering, strangling that which is living. The representation of movement by means of thought always makes coarse, kills, and not only by means of thought, but also by sense perception, and not only of movement, but every concept. And in this lies the essence of dialectics. And precisely this essence is expressed by the formula, the unity, identity of opposites. Continuity and discontinuity matter. One of major questions of classical Greek philosophy was, is matter innately divisible? Leucippus and Democritus, both of Abdera, and Epicurus of Athens, maintained that matter was composed of ultimately indivisible particles, atoms. Schrödinger states that, they invented the first discontinuity. 77 Democritus went further and declared, boldly, that the world is composed of atoms and void and all else is pure imagination. Democritus is also credited with being the RST to say that the Milky Way is composed of a myriad of distant stars. The great atomist would not grant continuity even to the mists of the heavens. Plato and Aristotle, to mention only the most famous, opposed the atomist view and maintained that matter was continuous and innately divisible. The question of the atomicity of matter was, for those times, a philosophical problem, and apart from being celebrated in Latin verse by Lucretius in his The Nature of Things, the idea lay dormant for 1,700 years. Interest was revived in Europe by the publication of a commentary on Epicurus by Gassendi, and, before long, Boyle, Descartes and Newton were convinced that an atomic theory of matter was necessary to explain the observations of physics. It was left to the chemists, however, to give the idea new life at the beginning of the 19th century. John Dalton revived the theory in 1803 to explain the laws of chemical combination. Armedio Avogadro, in 1811, in interpreting the laws of chemical combination of gases, drew a distinction between atoms and molecules, and the discreteness of matter had to be an accepted scientific fact. But Avogadro's ideas passed unnoticed for half a century until Cannizzaro popularized them in 1858. Laplace, c. 1806, used the idea to explain the phenomena of surface tension. In the 19th century, Clausius, Maxwell, and Boltzmann based their kinetic theory on the molecular theory of matter, and were able to derive, theoretically, well-known experimental laws of macroscopic behavior. The discreteness of electricity was implicit in Faraday's laws of electrolysis, though Faraday himself, who introduced the word ion, used it as a collective concept. In 1881, Helmholtz, in his Faraday lecture, indicated the atomicity of electricity. In 1887 Arrhenius gave us a consistent theory of the corpuscular ion. In 1891, George Ionson Stoney in Anticipation, gave the name electron to the fundamental particle of electricity. In May 1897, Thomson succeeded not only in proving its existence but also measuring its properties. The electron was found to be a negatively charged particle. The atom being electrically neutral, a positively charged particle had to exist. With the discovery of radioactivity by Henry Becquerel, its further study by Pierre and Marie Curie, and the work of Rutherford, a positively charged particle was discovered, and, in 1920, named the proton. In 1919, Rutherford successfully smashed the atom and also transmitted it, and the atom was thereafter indivisible, as de Broglie has aptly commented, only etymologically. In a curious passage in Materialism and Empirio-Criticism, we nd. It has become possible to reduce matter to electricity. The atom can be explained as resembling an innately small system, within which negative electrons move around a positive electron. 3 degrees Lenin wrote these lines in I-908. We do not know the source of Lenin's scientific information, as the bibliography mentions only the work of Thomson, The Corpuscular Theory of Matter, 1907. Thomson's model of the atom, while being a unity of oppositely charged particles, was certainly not an orbital one. The nuclear atom was conceived by Rutherford at Manchester only in February L9LL, and his results published in the Philosophical Magazine of June of that year. It is thus significant that Lenin, in Anticipation, accepted the orbital model as the correct one for the given historical period and hailed it as another corroboration of dialectical materialism. Continuity and discontinuity, energy. In 1704, Sir Isaac Newton posed the problem, are rays of light not very small corpuscles emitted by luminescent bodies? To the end of his days he refused to give a definite answer to the question. The experimental evidence accumulated in the 18th and 19th centuries led to the adoption of the wave theory of light. According to this view, light consists of waves which are continuous and undulatory. The wave theory achieved spectacular success with Maxwell's prediction of the existence of electromagnetic waves, and their experimental discovery by Hertz in 1888. They were used in sending wireless signals by A.S. Popov in Russia and a little later by G. Marconi in England. At the same time, Maxwell, in effect, undermined the wave theory of light by his theoretical discovery of the pressure of light. This was experimentally proved by P.N. Lebedev in 1900 and in 1907, 10. The inescapable conclusion, ignored by scientists until Einstein, was that electromagnetic waves do have momentum deemed as mass times velocity. I. The photoelectric effect, the emission of electrons by the absorption of light, was discovered by Hertz in 1887 and studied by W. Hallwachs and explained by Stoletov in the next year. I. On November 8, 1895, W.C. Röntgen of the University of Würzburg discovered X-rays. According to G.P. Thomson, this discovery forms indeed an epoch, dividing the old physics from the new, the physics of continuity from that of the discontinuous units. Y8. I. On December 14, 1900, Max Planck, as a result of his studies in the radiation of heat, was compelled to put forward his revolutionary hypothesis that energy is emitted in discrete packets, which he called quanta. He introduced a new universal constant h, now known as Planck's constant, which connects two fundamental physical quantities by the simple formula, energy equals the frequency multiplied by h. For VE years this concept found no other uses. Then, on September 26, 1905, Einstein in his analysis of the unity of opposites 57 phenomena of the absorption of light announced that he was compelled to assume that light was not only discrete in emission but also corpuscular in nature. Einstein's particles of light were later named photons. In the same year Einstein made the profound discoveries that all forms of energy possess inertia, and that energy and mass are interconvertible. He gave us the epoch-making formula connecting energy and mass, E equals mcz, where c is the velocity of light. What, then, is light? Wave or particle? It is said that W.L. Bragg once made the flippant confession that in keeping with his lecture timetable, on Mondays, Wednesdays and Fridays, light consisted of waves, and that on Tuesdays and Thursdays, of particles. His slightly serious explanation. A photon consists of a wave in the future and a particle in the past. Is imaginative, but takes us no further. Compton was much more helpful when he wrote, "Whenever radiation does something, it does it as particles." 87i. In 1905, Henry Poincare in The Value of Science announced a crisis in physics, the principles of which were in ruins. 8 Abel Ray, in 1907, declared that matter has disappeared. 9. Lenin devoted considerable attention to the crisis, to the extent of travelling from Zurich to London in May 1908, to read the latest literature in the British Museum. He devoted a whole chapter in his Materialism and Empiric Criticism to an analysis of the views of Poincare and Ray. There, he made the correct diagnosis of the crisis: modern physics is in travail, it is giving birth to dialectical materialism. 9. Within a few years, Planck's constant h became ubiquitous in physics, and was soon enthroned as the queen of the microcosm. In 1913 Sir Ernest Rutherford and Niels Bohr used h in their theory of atomic structure, in which the energy of electrons in their orbits had discrete values, integral multiples of h. Further, orbital electrons could only move in specific orbits, a concept that implied the discreteness of atomic space. Louis de Broglie 1ie*, in 1923, took the concept of wave-particle duality to its logical conclusion by postulating the existence of the particle wave. Matter on the atomic scale was both corpuscular and undulatory. Each particle has, associated with it, a wave the frequency of which equals h divided by the product of mass and velocity. Scientists were incredulous until 1927, when Davison and Germer in the USA and G.P. Thomson in England produced experimental evidence of de Broglie's matter waves. With the recent advances in laser technology, the wave concept has come to the fore again. Niels Bohr pointed out in 1927 that we need complementary concepts to explain the phenomena of light. Einstein has written of two contradictory pictures of reality. Separately neither of them fully explains the phenomena of light, but together they do. 9 Wolfgang Pauli has observed that, after the work of Einstein, it became clear that the existence of the quantum of action implies a radical change in the laws governing microscopic phenomena. In the case of radiation, this change is expressed in the contrast between the use of the particle picture and the wave picture for different phenomena. 92. In 1929, P.A.M. Dirac, while working out a synthesis of the known properties of the elementary particles, found another particle, a positive electron, jumping off the tip of his pencil. Physicists were incredulous until 1932, when Anderson in the USA and Blackett and Accialini in England photographed this antiparticle, the positron. In the same year, 1932, Chadwick discovered the neutron, the existence of which fundamental particle was predicted as far back as 1920 by Ernest Rutherford. Soon other particles and antiparticles began jumping off the tips of other pencils. In 1930, Pauli predicted the existence of another elementary particle, which, Fermi, Italian style, christened the neutrino. 26 years later, in 1956, it was detected by scientists in the USA. And when detected, it was found to coexist with its opposite, the antineutrino. In 1935, the Iapans physicist Yukawa found it necessary to postulate the existence of a meson. Several varieties of these were detected in 1948. In 1955, Emilio Segre and his co-workers in the USA detected the antiproton. In 1956 the antineutron was detected. Physicists were, some time ago, chasing quarks and, as a matter of course, anti-quarks. And so we have a fundamental law in subatomic physics, which follows from Dirac's pioneer work, that every particle has its antiparticle, some particles being their own antiparticles. If, in the Rutherford-Bohr concept of the atom, electrons would be satisfied with playing a decorous game of musical chairs and flirting within their orbits in accordance with the rules of the quantum theory, the Dirac-Fermi-Pauli elementary particles are more amorous, fact, passionate, and interact ceaselessly. They enter into wild marriages, producing pairs of other particles, while annihilating themselves, or committing mutual suicide in the process. 93 We can well imagine the shade of Hegel nodding sagely, "I told you so." For a long time, in spite of all the accumulated evidence, Mach and Ostwald clung on to their positivism and refused to believe in the reality of atoms. Would that they had lived up to August 5, 1945 to explain to the hapless victims of Hiroshima and of Nagasaki of a few days later, that the atom was a mere mental construct. Continuity and discontinuity. We close our discussion with the views of some world-famous scientists. According to H.A. Lorentz, it is the quantum conditions that hold matter together and prevent it from completely losing its energy in radiation. 95 Louis de Broglie says that without discontinuity atoms would be unstable and matter could not exist. And again, reality cannot be interpreted in terms of continuity alone. Within continuity we must distinguish between certain individual entities. 97 The founder of wave mechanics, Erwin Schrödinger, states that the demand for continuity is something quite exorbitant and that nature herself seemed to reject continuous description. 98 From a lifelong study of nature, Darcy W. Thompson discovered, a principle of discontinuity is inherent in all our classifications, whether mathematical, physical, or biological. F99 And the mathematical analyst Dedekind told us long ago, if space has a real existence at all, it is not necessary for it to be continuous, many of its properties would remain the same even if were it discontinuous. Inertia and activity. Our fundamental premise is that change is universal. But also universal is inertia, a fundamental and active tendency of all things to avoid or resist change. Sir Isaac Newton aptly deemed inertia as the force of inactivity. Engels, in his notes, tentatively described inertia in the philosophical sense as only the negative expression of the indestructibility of motion. Degree 1. Inertia and activity are not only opposites, they interpenetrate. Inertia gives rise to activity. As we shall see, the effort of the activity is to counteract the change. Mechanics gives us two simple examples: a stretched spring tends to contract, a wound spring tends to unwind. From Ernst Mach we have the generalization: in every symmetrical system every deformation that tends to destroy the symmetry is complemented by an equal and opposite deformation that tends to restore it. In each deformation positive and negative work is done 1 degree 2. Pierre de la Fermat is credited with the first formulation of a variational principle, some examples of which we consider below. He extended his studies of the maxima and minima of mathematical functions to give these concepts a physical meaning. He gave a theoretical key to the laws of propagation, reaction, and refraction of light with his principle of L-Stim. This became an entirely new branch of mathematics, the calculus of variations. Stones roll downhill, water owes from higher levels to lower. In 1644, Evangelista Torricelli realized that when the center of gravity of a system was at its lowest, the system would be stable. This idea was given rigorous proof by Lagrange in his pioneer work Mécanique analytique. L degree 5. It is a universal principle and a fundamental theorem in analytical mechanics that the position of stable equilibrium or rest of a system is that of the least potential energy. Degree. The determination of the shape of a hanging chain is a rather complicated mathematical problem. The great Galileo thought, wrongly, as it turned out, that the shape was that of a parabola. The correct answer was worked out by James and John Bernoulli, Huygens, and Leibniz, who found it was a catenary. 1 degree 7. On the other hand, the physics of the problem is simple. The chain so hangs that its center of gravity is at its gravitational lowest. B. K. Once the solution to the statistical problem was found, it was natural that scientists should look for its dynamical analog. As Max Planck has noted, in science, analogies are seductive. Degree Maupertuis propounded the idea that economy is inherent in nature and therefore, is wreaked in all physical laws. According to his principle of least action, a system tends to keep its activity at a minimum. The principle was, for him, a universal law of repose, and the summary of his mathematical work. Unfortunately, he adduced teleological and theological reasons for the principle. He was severely criticized and few contemporaries saw its scientific significance. Darcy W. Thompson, while noting that the principle of least action explains nothing, it tells us nothing of causation, yet it illuminates a host of things, traces the idea back to Aristotle's aphorism, nature does nothing in vain. 3. And to Pupus, who suggested a principle of economy, in nature. The Italian physiologist Giovanni Alfonso Borelli in his De Motu Animalum wrote, the perpetual law of nature is to act with a minimum of labor, avoiding in so far as possible, inconveniences and prolixities. 5. His contemporary Newton observed that nature is pleased with simplicity, and affects not the pomp of superous causes. Leibniz at about the same time spoke of the best of all possible worlds. 1. Voltaire, Leibniz's much younger contemporary, seized on the. In 1760, Lagrange revived the idea and, following Euler, gave the principle of least action rigorous mathematical form, yet calling it a simple and general result of the laws of mechanics. The road leads on to other great discoveries, but it has now become steep and sufficient for us for the present to glance at the terrain before turning our attention to other aspects of opposition. William Rowan Hamilton and, after him, M.V. Ostrogradsky generalized the Lagrangian concept of least action. In 1900, Max Planck, as we have seen, introduced the idea of the discontinuity of energy and the quantum of action. The idea is there in the work of statistics by Gibbs and, later, Boltzmann in the 19th century, and in the work of de Broglie and Erwin Schrödinger in the new wave mechanics of the 20th. I. The principle of economy is used to explain many of the phenomena of capillarity and surface tension, the RST mention of which was made by the German scientist Saynes in 1751.113. Laplace explained the phenomena by visualizing that the molecules of an interface between two different forms of matter are subject to a pull downwards, and that therefore all surfaces have a surface energy. Surface tension is explained by a tendency to surface shrinkage 9, to an attempt to minimize the surface energy, to a principle of minimal areas. Asterisk. This also explains the spherical shape of liquid drops and hardened granules of once molten metal. Not only liquid drops, soap bubbles, and balloons, but also biological cell walls at the beginning of their formation, denning the relation between voltage, resistance and the current in an electrical circuit, can also be derived theoretically from the principle of least heat. A current in a branched circuit so divides itself that the heat produced in the circuit is a minimum. 2. There are two other important thermoelectrical effects. In I-821, Seebeck found that a difference in temperature of the junctions of a circuit of two dissimilar metals gives rise to an electric current. In 1834, Peltier discovered the inverse effect: a flow of current in such a circuit produces a difference in temperature. And what is significant is that a Seebeck difference in temperature causes a current in a direction opposite to a Peltier current. Arago obtained some beautiful experimental results in L824. He found that oscillations were damped if a metal sheet was placed under an oscillating agent, even if the sheet was of non-ferromagnetic material like copper. Similarly, a rotating copper disc was braked in a magnetic eld. The theory of eddy currents in explanation of these phenomena came after Faraday's discovery of electromagnetic induction. Faraday's lines of force, an invaluable aid in visualizing elds, have a tendency to shorten themselves and also to push themselves aside laterally, i.e., to undo themselves. The inertial aspect of the important phenomena of electromagnetic induction and self-induction was summed up, dialectically, in Lenz's law that an induced current opposes the cause which produces it. A dramatic experiment illustrates what we may be permitted to call electromagnetic inertia. A light metallic ring held near an alternating current electromagnet will experience a powerful mechanical resistance. The ring gets heated up and cannot be held by hand for long. When released, it is hung away. 1. We quote, without discussion, Erwin Schrödinger, Einstein's theory is a reduction of gravitation to the law of inertia. 25. In chemistry, this phenomenon is recognized in Le Chatelier's principle: if a system in equilibrium is upset by a change of conditions, the system reacts in such a way as to undo the effects of the change. Physiology has given us the theory of the Reac's arc. The reaction of living tissue to a stimulus is such that the further excitation by the stimulus is avoided. One involuntarily drops a hot plate, or reacts, again involuntarily, to blinding light by blinking or shutting one's eyes. It is the inertia of the eye, persistence of vision, according to the physiologists, that enables us to see motion pictures. In 1873, Fechner gave us his physiological principle of the tendency to stability, according to which the organism tends to keep tensions at a minimum as an increase of tension is felt as pain and a decrease as pleasure. Clinical experience made Freud accept this principle in the eld of psychology. He wrote, "Instinct in general is regarded as a kind of elasticity of living things, as impulsion towards the restoration of a situation which once existed but was brought to an end by some external disturbance too." Freud's pleasure principle, so often misrepresented and misunderstood, is nothing other than a principle of least energy. Freud also conceived of a death instinct, the tendency of all organisms to attain the lowest possible level of energy. Inertia causes activity in the social behavior of men. Human beings are fundamentally conservative, weighed down by tradition, and kept in subjection by various forces, not the least of which, as Trotsky pointed out, is the force of habit. 27. In his letter on tactics, Lenin reminded the Bolsheviks that the bourgeoisie maintains itself not only by force but also by virtue of the lack of class consciousness, the clinging to old habits, the browbeaten state and lack of organization of the 21st-28 in 1920, he reminded the party again that the power of the bourgeoisie lies not only in the strength of international capital, but also in the force of habit. Trotsky observed that this very characteristic gives rise to progress. As a general rule, man strives to avoid labor. Love for work is not at all an inborn characteristic, it is created by economic pressure and social education. One may even say that man is a fairly lazy animal. It is on this quality, in reality, that is founded to a considerable extent all human progress, because if a man did not strive to expend his energy economically, did not seek to receive the largest possible quantity of energy, there would have been no technical development or social culture. It would appear, then, from this point of view that human laziness is a progressive force 3-degree. Determinism and probability *. At the dawn of history, the Chaldeans, after many years of observation, discovered regularities in the motion of heavenly bodies. We may now smile at their cosmogony, but their observations were undoubtedly correct and useful. Basing his calculations on the Chaldean laws, Thales was able to predict the eclipse of the sun in 585 BC. The Greeks left us a small legacy of scientific laws, the law of reaction of light, the laws of the lever and the law of rotation. Centuries later Kepler gave us the laws of planetary motion, and Galileo the law of falling bodies and the motion of projectiles. Newton, in his masterly synthesis, Principia, 1687, showed that the same laws of motion applied to both celestial and terrestrial phenomena, that, as far as gravitation was concerned, planets were no different from apples. The concept of determinism came from the French materialist to the physical scientism, and with the work of Descartes and Newton began to dominate them. Laplace, in a famous passage, declared the condens of the early 19th century in the Cartesian ideal that, given the initial conditions and the laws of motion, all events are predictable. We may regard the present state of the universe as the effect of its past and the cause of its future. An intellect which at any given moment knew all the forces that animate nature and the mutual position of the beings that compose it, if this intellect were vast enough to submit its data to analysis, could condense into a single formula the movement of the greatest bodies in the universe and that of the lightest atom, for such an intellect nothing would be uncertain, and the future, just like the past, would be present before its eyes. On January LST, 1801, the Italian astronomer Joseph Piazzi discovered Ceres, the RST observed asteroid, one of the minor planets that have their orbits between those of Mars and Jupiter. It was soon lost, but Gauss was able to predict its position as it emerged from behind the Sun. In 1781, William Herschel had recognized a new planet in the heavens and named it Uranus. Differences between the predicted and observed positions of this planet led, in 1845, to the prediction of the existence and location of another planet by John Adams in England, and independently, by Ujj. Leverrier in France. It was RST sighted by Gall in Germany in 1846 and named Neptune. Finer observations indicated that Neptune alone could not account for the irregularities of the orbital movement of Uranus. In our century, Percival Lowell of the USA predicted the existence of the ninth planet, which was photographed by Clyde W. Tombaugh in 1930, after Lowell's death, and named Pluto. As Schrödinger has noted with regard to determinism, when applied to celestial bodies this theory has been triumphantly confirmed. Before it, ironically, the very scientists who established the concept of determinism also laid the foundations of the study of the laws of chance, or random, effects. Many great names are associated with work in this field. We cannot name them all, we mention a few. Galileo, who studied not only the motion of cannon balls, but also the fall of dice, wrote what was probably the RST paper on probability. In their correspondence on the games of chance, Pascal and Fermat summed up, on a mathematical basis, all the previous work on the subject. Huygens made his contributions. Newton suggested the possibility of explaining macroscopic phenomena by a molecular theory of matter. In 1693, Edmund Halley, after whom the famous comet is named, studied the statistics of mortality. K. No one can predict, scientifically, when an individual will die. But statistics indicate what percentage of a given population will be dead at a given point in time. I. Jacques Bernoulli in his Ars Conjectandi posthumously published, hinted at the existence of a law of large numbers, and its possible applicability to social phenomena. Abraham de Moivre, who had already written his Doctrine of Chances, discovered the normal distribution curve, a technical term for a probability graph. St. Poisson gave us an explicit formulation of the law of large numbers in his researches, calling it a universal law: the larger the sample, the less the deviation from the mean. 35 Laplace, as we have seen, a convinced spokesman for determinism, independently discovered the normal distribution curve, and applied it to mathematical as well as physical problems. The quotation on determinism we have used above comes, in fact, from his essay Philosophique sur les probabilités. The Belgian astronomer L.A.J. Vitelot pioneered the use of statistics in the study of human stature and was perhaps the RST to use statistical curves. 370 Introduction to Philosophy of Marxism. Gauss developed the mathematics of the application of statistics to astronomical observations and discovered a distribution curve named after him. Thus scientists established that there is some order in seeming chaos, and vice versa, that there are statistical or collective truths. James Clerk Maxwell has given us a graphic example: we cannot do better than observe a swarm of bees, where every individual bee is ying furiously, RST in one direction and then in another, while the swarm as a whole is either at rest or sails slowly through the air. 7 Other examples of statistical shapes are flamesm, cloud slow, jets of water, fountains and waterfalls, piles of sand and heaps of grain, smoke from a chimney or funnel, or for that matter, from a cigar or cigarette. On the astronomical scale we have the shapes of solar arrays and of the distant nebulae. A famous case in the history of science is that of Saturn's rings. Galileo, who unraveled many astronomical riddles, could not, to the end of his days, with his weak telescope and also his poor eyesight, explain what he described as ears of Saturn. It was Huygens who RST saw and described the rings of Saturn. Maxwell proved, mathematically, that the rings could not be solid, but had to be constituted of myriads of fragments. It was, and is, of course, manifestly impossible to write down, leave alone solve, all the determinist equations of motion for a myriad of molecules. An entirely new approach was necessary. This was found by the genius of James Clerk Maxwell. In the words of G.P. Thomson, Maxwell was the RST to see the possibility of extracting order from the chaos. He proved mathematically that just because the motions and collisions are random, the distribution of energy among the particles is finite and can be calculated. 1. The apparent aimlessness of individuals is compensated for, to satisfy the scientists and to be more exact, is swamped, by the fact that the system as a whole is subject to its own laws. Max Planck called statistics the study of wholesale effects, and de Broglie that of en masse phenomena. Max Born has claimed that all laws of nature are really laws of chance. 2. His emphasis should have been on the word law. Hyman Levy has expressed the idea better: there is diversity in detailed behavior coupled with uniformity in mass behavior. 43. A basic randomness builds up to a systematic law. Sir Francis Galton *, who spent a lifetime in the study of statistics, concluded in his Natural Inheritance: I know of scarcely anything so apt to impress the imagination as the wonderful form of cosmic order expressed by the law of frequency of error. The law would have been personified by the Greeks and deified, if they had known it. It reigns with serenity and in complete self-effacement amidst the wildest confusion. The huger the mob and the greater the apparent anarchy, the more perfect its sway. It is the supreme law of unreason. Whenever a large sample of chaotic elements are taken in hand and marshaled in the order of their magnitude, an unsuspected and most beautiful form of regularity proves to have been latent all along. 5. Galton has described for us what is called his toy, a device that dramatizes the Gaussian distribution. If sand is poured from the top of a sloping tray studded with equally spaced pins, the bell-shaped curve develops as we watch. All of us have seen the haphazard motion of smoke or dust particles in sunbeams. Robert Brown, a Scottish botanist, in 1827, drew the world's attention to the random motion of pollen grains in water. This was explained by Christian Wiener as a phenomenon of molecular bombardment, and in 1905, Einstein and, independently, Smoluchowski derived a statistical explanation. The study of radioactivity at the turn of our century has given us the concept of radioactive half-life. We cannot predict which atom of a radioactive element will disintegrate at a given moment, but we can say, for example, that half the atoms of uranium will decay in 4,500 million years. Statistics and the mathematics of probability are now indispensable tools in the scientific study of natural and social phenomena. We mention the names of that unsung American genius Josiah Willard Gibbs, of Ludwig Boltzmann who placed the Clausius-Helmholtz second law of thermodynamics on a statistical basis, of Einstein and Bose, of Fermi and Dirac who applied statistics to subatomic particles. A discussion of their work is beyond the scope of this work. Werner Heisenberg and Erwin Schrödinger were compelled to use the concept of probability in their work on wave mechanics. In the words of the latter, and so we have the paradox that, from the point of view of the physicist, chance lies at the root of causality. 7. Way back in 1813, Hegel gave the solution to the paradox. In Engels' words, Hegel came forward with the hitherto unheard of propositions that the accidental has a cause because it is accidental, and just as much also has no cause because it is accidental, that the accidental is necessary, that necessity determines itself as chance, and, on the other hand, this chance is rather absolute necessity. In his Wage, Labor and Capital, Marx, referring to the price of commodities, pointed out that the total movement of this disorder is its order. 9. In Capital, he wrote, the division of labor within the society brings into contact independent commodity producers, who acknowledge no other authority but that of competition, of the coercion exerted by the pressure of their mutual interests, just as in the animal kingdom the bellum omnium contra armis more or less preserves the conditions of existence of every species. 5. He also observed that under capitalism, inherent laws impose themselves only as the mean of apparently lawless irregularities that compensate one another. 5. Engels discussed the subject in his Ludwig Feuerbach where he wrote of the regularity inherent in accidents. 3 feet 52 inches. In nature and also up to now for the most part in human history, these laws assert themselves unconsciously, in the form of external necessity, in the midst of an endless series of seeming acci_dents. I-153. Thus the conics of innumerable wills and individual actions in the domain of history produces a state of affairs entirely analogous to that prevailing in the realm of unconscious nature. Historical events thus appear on the whole to be likewise governed by chance. But where on the surface accident holds sway, there actually it is always governed by inner, hidden laws, and it is only a matter of discovering these laws. 5. In the concluding section of Origin of the Family, Engels wrote, but chance is only one pole of an interrelation, the other pole of which is called necessity. In nature, where chance also seems to reign, we have long ago demonstrated in each particular eld the inherent necessity and regularity that asserts itself in this chance. What is true of nature holds good also for society. 55. In his correspondence Engels explained. Thus there are innumerable intercepting forces, an innate series of parallelograms of forces which give rise to one resultant, the historical event. This may itself be viewed as the product of a power which works as a whole unconsciously and without volition. Thus history has proceeded hitherto in the manner of a natural process and is essentially subject to the same laws of motion. 315 degrees Lenin, in his summary of Marxist economics, wrote, it is quite natural that in a society of separate producers of commodities, who are united only by the market. A conformity to law can be only an average, social, mass manifestation, with individual deviations in either direction mutually compensating one another. 57. Trotsky has observed that Marx solved the fundamental puzzle, how in capitalist society, in which each man thinks for himself and no one thinks for all, are created the relative proportions of the various branches of economy indispensable to life. The worker sells his labor power, the farmer takes his produce to the market, the money lender or banker grants loans, the storekeeper offers an assortment of merchandise, the industrialist builds a plant, the speculator buys and sells stores, stocks, and bonds, each having his own considerations, his own private plan, his own concern about wages or prod. Nevertheless, out of this chaos of individual strivings and actions emerges a certain economic whole which, true, is not harmonious, but contradictory, yet does give society the possibility not merely to exist but even to develop. This means that, after all, chaos is not chaos at all, that in some way it is regulated automatically, if not consciously. 53. Truth and error. We have seen that scientific laws are limited generalizations. Truth and error, Engels pointed out, like all concepts which are expressed in polar opposites, have absolute validity only in an extremely limited L. 59. Every truth, insofar as it is limited, contains error. Engels commented on this thesis of Hegel. Truth, the cognition of which is the business of philosophy, was in the hands of Hegel no longer an aggregate of niche dogmatic statements, which once discovered, had merely to be learned by heart. Truth lay now in the process of cognition itself, in the long historical development of science, which mounts from lower to ever higher levels of knowledge without ever reaching, by discovering so-called absolute truth, a point at which it can proceed no further, where it would have nothing more to do than to fold its hands and gaze with wonder at the absolute truth to which it had attained. To quote Hegel himself, the more the ordinary mind takes the opposition between true and false to be XED, the more it is accustomed to expect agreement or contradiction with a given philosophical system, and only to see reason for the one or the other in any explanatory statement concerning such a system. It does not conceive the diversity of philosophical systems as the progressive evolution of truth, rather it sees only contradiction in the variety. In his preface to Marx's The Poverty of Philosophy, Engels made an interesting observation, but what formally may be economically incorrect, may all the same be correct from the point of view of world history. Formal logic. Classical, Aristotelian logic takes as its fundamental premise the law of identity, the statement that a thing is identical with itself. Expressed in a formula, A is A. Its any_gative_ form, the law of contradiction states that a thing is never different from itself, that A is not and cannot be non-A. In combination, these laws give rise to a third, the law of the excluded middle. Either A is B, or it is non-B, it cannot be both. These three laws of formal logic, which Aristotle made the basis of his system, had a tremendous significance in the history of human thought, just as specific formulations were of great importance in the various branches of science. Way back in the mists of time man must have realized that it is the same sun that rises every day, but there was a Red Indian folk tale that a new sun rises every day, while the old ones collect at the bottom of the sea. Astronomy took a leap forward when Pythagoras realized that the morning star and the evening star were different positional appearances of the planet Venus. 2 Chemistry was placed on a new basis with the discovery of the law of conservation of matter, that matter cannot, in all its combinations and dissociations, be created or destroyed. Proust's law of constant composition, that chemical compounds are identical, no matter how they are obtained, is only a chemical formulation of the law of identity. A is A. Physics and physiology opened up new horizons with the formulation of the equivalence of heat and energy and the law of conservation of energy. Classification in biology is nothing other than the application of the law of identity. William Ward does not exaggerate when he writes, "We could neither act nor think correctly without consciously or unconsciously obeying this law." If we could not recognize ourselves as the same person from moment to moment and from day to day, we would be lost. But the law of identity is no less valid for the rest of the universe as for human consciousness. It applies every day and everywhere to social life. All science as well as all intellectual behavior rests in part upon this law of identity. The law of identity directs us to recognize likeness amidst diversity, permanence amidst changes, to single out the basic similarities between separated and apparently different instances and entities, to uncover the real bonds of unity between them, to trace the connections between different and consecutive phases of the same phenomena. We have already seen, however, that all of existence is the unity of opposites, and that Zeno demonstrated the breakdown of the law of identity when applied to motion: either the arrow is there or it is not there. Plekhanov in his delightful essay Dialectic and Logic 165 and recently William Ward in his detailed study and introduction to the logic of Marxism have, following Hegel, shown the limitations of the laws of formal logic. Brie, the laws of formal logic are applicable, RSTLY, within specific limits, and secondly, on condition that there is continuity, in other words that there is no change. Knowing that change is universal, we see immediately that despite their usefulness and importance, the laws of formal logic have an extremely limited range of validity. It was Hegel who was responsible for the modification of the laws of logic that enlarged the range of their validity and made possible their applicability to changing phenomena. He transformed logic into a dynamic science and called it dialectics. Identity and difference. For Aristotle, identity excludes difference. With Hegel, identity and difference are a unity. In Aristotle's formal logic A is A, and never non-A. In Hegel 1's dialectics A is A as well as non-A. Thus, as Otto Ruhl pointed out, whereas the old logic stated everything is identical with itself, nothing contradicts itself, Hegel counterposed, nothing is identical with itself, and everything contradicts itself. 57. Hegel criticized the old logic. The thinking of this metaphysics was not free and true in the objective sense, as it did not leave it to the object to develop freely out of itself and its definitions, but took it as something ready-made. This metaphysics is trogmatism, because, in accordance with the nature of null definitions, it had to assume that, of two antithetical assertions, one was necessarily true, and the other necessarily false. Degree B. Contrasting his dialectics, Hegel wrote, instead of speaking by the maxim of the excluded middle, we should rather say, everything is opposite. Neither in heaven nor on earth, neither in the world of mind nor of nature, is there anywhere such an abstract either or as common sense thought maintains. All that is concrete, with difference and opposition within itself. 9. Hegel ridiculed the old logic. It is asserted that the maxim of identity, though it cannot be proved, regulates the procedure of every consciousness, and that experience shows it to be accepted as soon as it is apprehended. To this alleged experience of the logic books may be opposed the universal experience that no mind thinks or forms conceptions or speaks, in accordance with this law, and that no existence of any kind whatever conforms to it. Utterances after the fashion of this pretended law are, as they deserve to be, reputed silly. 7. Hegel pointed out that every ordinary statement does not take the form A is A but in fact contains concrete truth and takes the form A is B and implies the unity of identity and difference. 7. Gertrude Stein's A rose is a rose is a rose may be good poetry, but as a statement of identity, is, to use Hegel's phrase, insufferably vacuous. 72. Marx commented, it is typical of bluff common sense that where it manages to see difference, it does not see unity, and where it sees unity, it does not see difference. If perchance, it sets up distinguishing qualities, it immediately petries them. 3 feet 73 inches. Engels noted that abstract identity, with its opposition to difference, is in place only in mathematics, an abstract science which is concerned with creations of thought. He agreed with Hegel that every time one says John is a man, or the lily is a plant, or the rose is red, that is, every time the singular is equated to the general, where the predicate is necessarily different from the subject, the fact that identity contains difference within itself is expressed in every sentence. That from the outset identity with itself requires difference from everything else as its complement, is self-evident. 7. Most natural scientists imagine, Engels complained, that identity and difference are irreconcilable opposites, instead of one-sided poles which represent the truth only in their reciprocal action. In the inclusion of difference within identity 75, writing in lighter vein to Conrad Schmidt, Engels gave a down-to-earth example of the unity of identity and difference. For instance, you as a bridegroom, have a striking example of the inseparability of identity and difference in yourself and your bride. It is absolutely impossible to decide whether sexual love is pleasure in the identity in difference or in the difference in identity. Take away the difference or the identity and what have you got left? We can readily agree with Engels, the maleness of man would be meaningless without woman, the opposite sexes are mutually complementary, and are composite subdivisions of man. The unity of opposites. W.T. Stace, in his excellent commentary on the philosophy of Hegel, summed up this aspect of dialectics. Hegel's audacity and originality consists simply in this, that he explained and showed in detail how it is logically possible for two opposites to be identical while yet retaining their opposition. If we can only say A is A, the inite is the inite, then A must remain a forever, the inite must remain inite, and therefore sterile within itself, forever, and the night world can never arise out of it. We can only solve this problem if the inite contains the night, just as being contains non-being, if the inite is the night, if A is non-A. It is of paramount importance to observe that the identity of opposites does not exclude the opposition of those opposites. A and non-A are identical. But they are also distinct. It is not only an identity of opposites, it is also an identity of opposites. The opposition is just as real as the identity. Stace adds that Western thinkers stress differences and ignored identity. They said A is not non-A. Indian thinkers stressed the identity and ignored the differences. They said A is A. Hegel said A is non-A while recognizing polarity. Hegel emphasized that the poles are inseparably distinguished. 7. Engels wrote, closer investigation shows us that the two poles of an antithesis, like positive and negative, are just as inseparable from each other as they are opposed, and that despite all their opposition they mutually penetrate each other. 18. In contrast to dialectics which sees the coexistence, the unity and interpenetration of opposites, metaphysics provides us with empty abstractions. Engels criticized the metaphysicians. To the metaphysician, things and their mental rexes, ideas, are isolated, are to be considered one after the other and apart from each other, are objects of investigation, xed, rigid, given once for all. He thinks in absolutely irreconcilable antitheses. For him a thing either exists or does not exist, a thing cannot be at the same time be itself and something else. Positive and negative absolutely exclude one another, cause and effect stand in rigid antithesis one to the other. He repeated the same point in his letter to Conrad Schmidt, what these gentlemen all lack is dialectics. They always see only here cause, their effect. That this is a hollow abstraction, that such metaphysical polar opposites exist in the real world only during crises, while the whole vast process goes on in the form of an interaction, though of very unequal forces, the economic movement being by far the strongest, most primeval, most decisive, that here everything is relative and nothing absolute, this they begin to see. Hegel has never existed for them. 32. Dialectics, wrote Lenin, in the proper sense is the study of contradiction in the very essence of objects. Not only are appearances transitory, mobile, fluid, demarcated only by conventional boundaries, but the essence of things is so as well. Lenin noted that, according to Hegel, thinking dialectically means comprehending the antithesis in its unity. 3.8 In brief, he said, dialectics can be deemed as the doctrine of the unity of zero posits. 135 The division of the one and the cognition of its contradictory parts is the essence of dialectics. 9 We can appreciate the genius of Heraclitus who, some 2,300 years ago, declared that opposition is the ruling principle of the universe. 87 Everything is a balance of, and a battleground for, opposing forces. Difference is the essence of harmony. 189 I. Let us now make our survey brief. We have to pass on. In chemistry we have the opposite processes of oxidation reduction, catalysis inhibition, analysis synthesis, exothermy endothermy, and so on. In the electrolytic apparatus we have the electrodes described as anode and cathode, in the ionic theory of Svante Arrhenius, anions and cations, positive and negative. In nuclear physics there are the now, unfortunately, well-known phenomena of fission and fusion. Botanists tell us that all the phenomena of plant physiology are governed by opposing principles. Phototroism, the growth of the shoot of the plant towards light, is complemented by the antiphototropism of the root, a tendency to grow away from light. Geotropism, the growth of roots towards the pull of gravity, is opposed by a negative or anti-geotropism on the part of the shoot. Hydrotroism, the root's attraction towards water has its opposite tendency on the part of the shoot. Haptotropism. The tendency of roots to avoid hard substances is complemented by the tendency of climbing stems to twine round hard objects. Leaving the apparent exceptions aside, it does not require much observation or imagination to realize that, without these opposite tendencies, no plant can grow. In histology we have the polarity of cells, which is most marked in embryonic and regenerative cells. In 1874, Bruck declared his contents that physiological LNRCCS would with further research be ultimately reduced to two, attraction and repulsion. 9° In the physiological study of response to stimuli we come across excitation and inhibition. Ivan Pavlov has told us that, these two processes, it is necessary to add, are coexistent and equally important in the nervous activity. 91. The list is inexhaustible, and this is, perhaps, a convenient point to stop. If we have, despite Mephistopheles' advice, ranged from science to science, it has not been in vain. 192 In every phenomenon we have studied we have found, after Heraclitus and Hegel, the existence of and the unity of opposites. Discussing the situation in his special branch of physics, Erwin Schrödinger wrote, in I 935, we are confronted with the profound logical antithesis between either this or that, this as well as that. 93. 60 years earlier, in I 875, Engels in his studies had noted dialectics, which likewise knows no hard and fast lines, no unconditional, universally valid either, or and which bridges the fixed metaphysical differences, and besides either, or recognizes also in the right place both this, and that, and reconciles the opposites, is the sole method of thought appropriate in the highest degree to the stage. 9. It was perhaps philosophical intuition that made Schiller warn the philosophers and the scientists. Be opponents. The time is not ripe to join hands. Only on different roads will you come to the truth. L95 Chapter 7. Development through contradiction. Truth through connect. The word dialectics is derived from the Greek adjective dialektik, argumentative * Socrates, sometimes described as an intellectual midwife, is said to have perfected the method of reaching for the truth through debate, discourse, and disputation. A proposition would be contradicted and a new proposition reached in the union between the original proposition and the contradiction. The new proposition would, in turn, be contradicted, leading to a closer approximation to the truth. Long ago, the poet Goethe observed that the solution to any problem contained a new problem. In recent times, the scientist Max Planck pointed out that the solution of one problem only unveils the mystery of another. Niels Bohr often told his students, every sentence I utter is to be understood as a question and not as an affirmation. 3. The process is best summarized in Fichte's formula. Thesis, antithesis, synthesis. The synthesis, its antithesis, a higher synthesis, and so on. Marx, in a similar wordplay, said that dialectics reached towards the truth by proposing, opposing, and composing the differences. 5. Lessing once observed, truth has gained from every controversy. Degree. In one of his early writings, Marx pointed out, not only the result but also the road to it, is part of the truth. The investigation of truth must itself be true. True investigation is unfolded truth, the disjuncted members of which unite in the result. 7 Lenin often repeated, truth is a process. 8 One of his favorite quotations, according to N.K. Krupskaya, was the French proverb, truth is a consequence of connecting opinions. *9 Marxism recognizes no other way of reaching for the truth. It has no place for inspired revelations claiming to be the null word on all matters. In fact, Marx criticized the doctrinaires who would say in effect, here is the truth, kneel before it. Degree. Trotsky wrote in reference to a specific situation. There is no book which sets in advance the correct orbit for the RST workers' state. The head does not and cannot exist which can contain the ready-made formula for socialist society. The roads of economy and politics must still be determined only through experience and worked out collectively, that is, through a constant connect of ideas. The cause of change. It is not only in the eld of ideas that change is brought about by contradiction. The whole of nature moves forward through this process. At a very early stage of his intellectual development, man recognized that external causes or agencies could produce effects or changes. In fact, the RST act of early man that was not motivated by instinct implied a recognition of this principle. It was not long before attempts were made to deem the connection between cause and effect. Let us take a gigantic leap across the history of human thought, and examine one of the most important scientific formulations of SLLTL1, a relationship. Classical mechanics rests on the formulations of Sir Isaac Newton, the RST of whose laws of motion deems force as the external agency that causes acceleration, a change in the state of rest or uniform linear motion of a body. In such views of development, the cause of change is external. By counteropposing force and acceleration as cause and effect, Newton arrived at a simple law of motion which states that force is equal to mass multiplied by acceleration. This is now recognized as the fundamental theorem of dynamics, too, and has proved to be supremely important in the investigation of the physical world. It is a milestone in the history of science. Hegel criticized Newton's view. He insisted that what was separable in thought was not separable in nature. To quote him on the subject of Newton's laws, such separation of external and essential motion belongs neither to experience nor to the motion, but only to abstracting reaction. It is one thing to distinguish them, as is necessary, as well as to characterize them mathematically as separate lines, to treat them as separate quantitative factors, and so on. It is another thing to regard them as physically independent existences. 3. Commenting on Thales' views, Hegel wrote, "It is better to say that a magnet has a soul than that it has an attracting force. Force is a kind of property separable from matter, while soul is this movement itself, identical with the nature of matter." 4. Hegel was obviously unaware of the dialectical formulation of Newton's law by D'Alembert in his treatise on dynamics. Taking Euler's formulation of Newton's second law, P equals mf, where P and F are vectors, D'Alembert transposed mf and wrote, P, mf equals 0. Expressing mf by I, a negative vector, Newton's law was written, P plus I equals 0. It was Hegel's immortal merit that he drew attention to the fact that changes are brought about by the inner contradictions of a system, that all things, by virtue of the inherent unity of opposites, are destined to self-movement and dvoe1 ont nt. This idea is not only Hegelian, but ancient. The Roman poet, Ovid, pronounced, "Every shape that is born bears in its womb the seeds of change." Benjamin Franklin wrote, "Every animal brings into the world among its original stamina the seeds of that disease that shall, nally produce its dissolution." 1 degree. Contradiction. Hegel pointed out that the coexistence, the unity, the interpenetration of opposites constitutes an inner and inherent contradiction, a basic instability in all things which leads to development and change. He said, all opposites which are taken as XED, such as, for example, night and innight, or individual and universal, are contradictory, not by virtue of some external connection, but rather are transitions in and for themselves. 7. He insisted, all things are contradictory in themselves. The existence of contradictions in all things gives rise to self-movement. In his encyclopedia Hegel wrote, contradiction, above all things, is what moves the world, and it is ridiculous to say that contradiction is unthinkable. 9. And again in his Logic, contradiction is the root of all movement and vitality, and it is only in so far as it contains a contradiction that anything moves and has impulse and activity. 2 Contradiction is the principle of all self-movement. Concisely, contradiction leads forward. 22 That which has no contradiction, according to Hegel, is sterile within itself. 23 Abstract self-identity has no vitality. 2 In explanation, Hegel wrote, something moves, not because it is here at one point of time and there at another, but because at one and the same point of time it is here and not here, and in this here both is and is not. We must grant the old dialecticians the contradictions which they prove in motion, but what follows is not that there is no motion, but rather that motion is existent. Contradiction. 2 One of the old dialecticians Hegel referred to is Zeno. Another is Heraclitus, who, with brilliant intuition, maintained that everything happens through struggle, which is the father of all things. Marx adopted Hegel's concept of inherent contradiction, and acknowledged that, the Hegelian contradiction, the main source of dialectics. He said, what constitutes dialectical movement is the coexistence of two contradictory sides, their connect and their fusion into a new category. 2 In answer to the American journalist John Swinton, who, in 1880, asked the aging Marx what he saw in the future, Marx replied, struggle, summing up in a word, the law of life. In his drafts for Anti-Düring, Engels noted, antithesis, if a thing is saddled with its antithesis it is in contradiction with itself, and so is its expression in thought. For example, there is a contradiction in a thing remaining the same and yet constantly changing, being possessed of the antithesis of inertness and change. Having seen that all things are a unity of opposites, we can appreciate that all things are, therefore, self-contradictory, unstable, changing and developing. Dialectics, observed Lenin, is the study of contradiction in the very essence of objects. 3 Lenin summarized, the condition for the knowledge of all processes of the world in their self-movement, in their spontaneous development, in their real life is the knowledge of them as a unity of opposites. Development is the struggle of opposites. The struggle of exclusive opposites is absolute, just as development and motion are absolute. 32 Rosa Luxemburg observed, historic development moves in contradiction, and for every necessity puts its opposite into the world as well. The capitalist state of society is doubtless a historic necessity, but so also is the revolt of the working class against it. Capital is a historic necessity, but in the same measure is its gravedigger, the socialist proletariat. 34. In 1892, Sigmund Freud set out his discovery of the existence of antithetic ideas that disturbed the coitus activity of the mind. On the psychoanalytic concept of repression, Freud said, we explain it dynamically, from the connect of opposing mental forces, and recognize it as the outcome of an active struggling on the part of the two psychical groupings against each other. 3. Chapter 8. The self-transformation of opposites. Hegel not only showed that contradictions lead to development, he also pointed out that development leads to negation, the self-transformation of a phenomenon into its opposite, the self-replacement of one form of existence by its antithesis, the self-suppression of all things. In his Encyclopedia, Hegel wrote, but the essence of the matter is that what is denied is not only limited from without, but is bound to be destroyed and to pass over into its opposite by virtue of its own nature. In explanation he said, we say, for instance, that man is mortal, and seem to think that the ground of his death is in extremal circumstances only, so that if this way of looking were correct, man would have two special properties, vitality and also mortality. But the true view of the matter is, that life, as life, involves the germ of death, and that the night, being radically self-contradictory, involves its own self-suppression. According to Hegel, this dialectical self-transformation is universal. To quote his encyclopedia again, wherever there is movement, wherever there is life, wherever anything is carried into effect in the actual world, their dialectic is at work. It is also the soul of all knowledge which is truly scientific. Dialectics gives expression to a law which is felt in all grades of consciousness, and in general experience. Everything that surrounds us may be viewed as an instance of dialectic. We are aware that everything night, instead of being inexorable and ultimate, is rather changeable and transient, and this is exactly what we mean by the dialectic of the night, as implicitly other than it is forced to surrender its own immediate or natural being, and to turn suddenly into its own opposite in his logic. Hegel repeated the point: the understanding may demonstrate that the idea is self-contradictory, because, for instance, the subjective is only subjective and is always confronted with the objective, that being is something quite different from the notion and therefore cannot be extracted out of it, and that likewise the night is only the night and the exact antithesis of the innate, and therefore not identical with it, and so on with all the determinations. Logic, however, demonstrates the opposite of all this, namely, that the subjective, which is to be the subjective only, the night, which is to be night only, the innate, which is to be the innate only, and so on, have no truth, but contradict themselves, and pass into their opposites. As an example, Hegel pointed out that every abstract justice carried to its logical conclusion becomes an injustice. In illustration, Plekhanov cited the pound of ash theme in Shakespeare's The Merchant of Venice. The idea goes back to ancient times. Terence in Lfunicus has the line, "Rigorous law is often rigorous injustice." We have already heard Juliet's confession. In the same play, we end the lines. Virtue itself turns vice, being misapplied, and vice sometimes by action dignified. And then there are the oft-quoted lines of William Congreve. Heaven has no rage like love to hatred turned, nor hell a fury like a woman scorned. And from Goethe we have, reason becomes unreason, right wrong. It must be emphasized that the Hegelian concept of negation is not artificial or mechanical, not a mere placing of a minus sign before. We regret that the following passage was omitted from page 95 after the citation from Goethe. Marx accepted Hegel's concept of negation: any development, whatever its substance may be, can be represented as a series of different stages of development that are connected in such a way that one forms the negation of the other. In no sphere can one undergo a development without negating one's previous mode of existence. 5. In I-873 Marx wrote, in its rational form, includes in its comprehension an affirmative recognition of the existing state of things, at the same time also, the recognition of the negation of that state, of its inevitable breaking up. Plekhanov emphasized, every phenomenon, by the action of those same forces which condition its existence, sooner or later, but inevitably, is transformed into its own opposite. 7. Lenin pointed out, that all dividing lines, both in nature and society, are conventional and dynamic, and that every phenomenon might, under certain conditions, be transformed into its opposite, is, of course, a basic proposition of Marxist dialectics. In his philosophical notebooks, he deemed this aspect of dialectics. Dialectics is the teaching which shows how opposites can be and how they happen to be identical, under what conditions they become identical, becoming transformed into one another. Why the human mind should grasp these opposites not as dead, rigid, but as living, conditional, mobile, becoming transformed into one another. 9. We also regret that the author's name has been incorrectly spelt in several places, and we apologize to him for this error. A given quality, but a self-transformation of a phenomenon into its opposite. Hegel warned that negation should not be abstract or empty, but that the self-contradictory resolves itself not into nullity, into abstract nothingness, but essentially only into the negation of its particular content. Degree. Engels, following Hegel, repeated that dialectical negation is not mechanical. Negation in dialectics does not mean simply saying no, or declaring that something does not exist, or destroying it in any way one likes. If a grain is crushed or an insect killed, it is not negation but destruction. Each class of things therefore has its appropriate form of being negated in such a way that it gives rise to a development, and it is just the same with each class of conceptions and ideas. Self-transformation. We have seen Tolstoy's man becoming unlike himself, when a hidden trait becomes a dominant characteristic. Error emerges from truth, justifying the old saying that the science of one age becomes nonsense in the next. The reverse is also true. Engels pointed out that, according to an old and well-known dialectical law, incorrect thinking, carried to its logical conclusion, inevitably arrives at the opposite point of departure too. Way back in 1749, Benjamin Franklin observed, "Even a bad solution read, and its faults discovered has often given rise to a good one." We have the interesting comment of Pareto, "Give me a fruitful error anytime, full of seeds, bursting with its own corrections. You can keep your sterile truth for yourself." Pain gives rise to pleasure, love comes into hate. Freud supported this view from experience. Clinical observation shows not only that love is with unexpected regularity accompanied by hate, and not only that in human relationships hate is frequently a forerunner of love, but also that in many circumstances hate changes into love and love into hate. Hegel said, "We say that all things must be submitted to the judgment of dialectics, and by the very fact we deem it as a universal, invincible force, which must destroy everything, no matter how lasting it may seem." Plekhanov commented, "The important thing is that Hegel's view of social phenomena is far more profound than that of people who know only one thing, namely, that there is no action without cause. Neither is that all. Hegel brought out a far more profound and more important truth. He said that every particular aggregate of phenomena in the process of its development creates out of its very self the very forces that lead to its negation, i.e., its disappearance, that consequently every particular social system, in the process of its historical development, creates out of its very self the social forces that destroy it and replace it by a new one." We can readily appreciate why the Russian radical Herzen hailed the Hegelian philosophy as the algebra of revolution. 7. The negation of living is contained in life itself, said Engels, supporting Hegel's point that vitality and mortality are not separable phenomena. Recognizing the self-suppressing tendency of life, he said, concisely, living means dying. 7. Once more let us pay tribute to Heraclitus of Ephesus, who, with profound intuition, maintained that the basic law of the world is the law of transformation into the opposite. 9. Chapter 9. Negation of the negation. No negation is, or can be, null. Each negation leads to a new series of opposites, disclosing them, giving rise to their interpenetration and connect, and these in turn, lead to a new negation. Each negation is thus negated, giving rise to unceasing development and change. Hegel explained, the bud disappears when the blossom breaks through, and we might say that the former is negated by the latter. In the same way, when the fruit comes, the blossom may be explained to be a false form of the plant's existence, for the fruit appears as its true nature in place of the blossom. These stages are not merely differentiated, they supplant one another as being incompatible with one another. But the ceaseless activity of their own inherent nature makes them at the same time moments of an organic unity, where they not merely do not contradict one another, but where one is as necessary as the other, and this equal necessity of all moments constitutes alone and thereby the life of the whole. From Engels we have another example from plant life. Let us take a grain of barley. If such a grain meets with conditions which for it are normal, if it falls on suitable soil, then under the influence of heat and moisture a specific change takes place, it germinates, the grain as such ceases to exist, it is negated, and in its place appears the plant which has arisen from it. the negation of the grain. But what is the normal life process of this plant? It grows, ours, is fertilized, and nally as soon as these have ripened on the stalk, dies, is in its turn negated. As a result of this negation of the negation we have once again the original grain of barley, but not as a single unit, but 10, 20 or 30-fold/2 angles added, that with plants that are molded by cultivation, each repeated negation of the negation improves the qualities of the plant. Point 3. He also cited the life cycle of the buttery, which pairs, lays eggs and dies, and then each egg after its various metamorphoses emerges, once again, as a buttery, in his polemic against the critics who ridiculed the law of negation of the negation, saying that oats do not grow according to Hegel. Plekhanov quoted the botanist P.H. van Tighem, who wrote that, whatever be the form of the plant, it reproduces itself in the same way as it was born, by dissociation. 5. T. With dialectical insight, Tom Paine observed, the sublime and the ridiculous are often so nearly related, that it is difficult to class them separately. One step above the sublime makes the ridiculous, and one step above the ridiculous makes the sublime again. Tolstoy, who had a deep understanding of human relationships, has left us a delightful short story, A Happy Married Life, which illustrates the negation of the negation very graphically. The passions of the RST period of love of a newly married couple transform themselves into misunderstanding and later hate. In turn, the hate turns into a new love based on gratitude, affection, and understanding. Freud was one of the RST psychologists to point out that the development of the sexual life of man is diphasic. At about the end of the FTH year of childhood, sexuality undergoes a lull in what he called the latency period. With the onset of puberty, psychological sex life re-emerges, reinforced by physiological changes, in its normal adult form. Point 7. Repetition of form. Each negation of the negation apparently brings us back to our point of departure. There is thus a repetition of form. Plekhanov commented, every phenomenon developing to its conclusion, becomes transformed into its opposite, but as the new phenomenon, being opposite to the RST, also is transformed in its turn into its own opposite, the third phase of development bears a formal resemblance to the RST/8. The negation of the negation is, according to Lenin, a development that repeats, as it were, stages that have already been passed, but repeats them in a different way, on a higher basis, a development, so to speak, that proceeds in spirals, not in a straight line. 9. This, Lenin noted, gives rise to the repetition, at a higher stage, of certain features, properties, etc., of the lower, and the apparent return to the old degree. T. Let us consider two examples from history. The English Civil War saw the smashing of the feudal power and the execution of Charles I. After the consolidation of bourgeois power in 1660, there was the Restoration. Another Charles was brought back to the throne on the invitation of Parliament. This was, however, only an apparent return to the old, the repetition at the higher, bourgeois, stage of state power of the monarchist features of the feudal. Charles II might have reigned, but it was Parliament that ruled. As the French ambassador at the time observed to Louis XIV, this government has a monarchical appearance because there is a king. But at bottom it is very far from being a monarchy/one. A similar development took place in France, which in 1789 witnessed the end of feudalism and Louis XVI. Napoleon Bonaparte crowned himself emperor in 1804 and was a monarch in the sense that he had the feudal trappings of a monarchy, a crown and a throne. In essence, however, he was the RST bourgeois dictator of France, as Cromwell was of England. A repetition of form should not blind us to the reality of the change of content. Superficial commentators have sought to prove the identity of the state forms in Nazi Germany and Soviet Russia. They ignore the basic difference between a capitalist state in convulsion and a workers' state, however degenerate. The destruction of democratic rights in the RST instance was acutely symptomatic of the last phase of a society in its death throes, In the second it was a retrogressive phase in the post-revolutionary development of a then economically backward society encircled by imperialism. Chapter 10. The transition from quantity to quality and quality to quantity. The most graphic law of dialectics and perhaps the easiest to grasp is the law of transition from quantity to quality. It was also probably the RST to be recognized. Hegel acknowledged, the ancients were aware of the connection by which a change appearing as merely quantitative turns into one which is qualitative. Let us, in passing, remind ourselves of the ancient fable, single rods can be easily broken, not so a faggot. As Aesop has told us, there is strength in numbers. Anaximenes of Miletus, in the 6th century BC, with his theory of condensation and rarefaction, propounded the idea that qualitative changes lead to quantitative ones. 2 Euripides in his Medea declared, when love is temperate, nothing is more enchanting, but save me from the other sword. Terence in his Eunuchus pointed out that rigorous law is often rigorous injustice. Ovid in his Metamorphoses observed, plenty makes me poor. In the Merchant of Venice we have, they are as sick that surfeit with too much, as they that starve with nothing, and in Romeo and _7 Juliet, too swift arrives as tardy as too slow. 104 Introduction to Philosophy of Marxism. Cervantes made Sancho Panza observe, many littles make a much. Engels has cited Napoleon Bonaparte, 2 Mamelukes were undoubtedly more than a match for 3 Frenchmen, 100 Mamelukes were equal to 100 Frenchmen, 300 Frenchmen could generally beat 300 Mamelukes, and 1,000 Frenchmen invariably beat 1,500 Mamelukes. A short story attributed to Tolstoy, 3 Rolls and a Cookie, is often cited in illustration of this law. It concerns a man who sought to satisfy his hunger, 3 rolls did not suffice, but when he added a cookie and felt saddest, he regretted that he had not eaten a cookie to start with and had spent money on the rolls. The unity of quantity and quality. Let us note the unity of quantity and quality, the fact that they are inseparably interrelated. Whenever we speak of concrete things, we have to specify them in terms of quantity as well as quality. We do not shop for sugar or anything else without specifying the quantity, nor do we merely ask for yards without stating whether we want cloth or barbed wire. In his encyclopedia, Hegel stated, quality determines quantity and quantity determines quality. This is a mutual, unsettled, dynamic actuation and unrest. 5 In measure, he wrote, quality and quantity are united. James Clerk Maxwell, in his address to the British Association in 1870, said, it was a great step in science when men became convinced that, in order to understand the nature of things, they must begin by asking, not whether a thing is good or bad, noxious or beneficial, but of what kind it is, and how much there is of it. Quality and quantity were then recognized as the primary features to be observed in scientific inquiry. 7. Limits. In practice, and even in theory, no process can be carried on indefinitely. There are finite limits, nodes as Hegel called them, beyond which the process becomes impossible or gives rise to new phenomena. Every child knows that there is a limit to the size to which a balloon can be blown, that there is a critical point beyond which quantity passes into quality, and the balloon ceases to increase in size and bursts. What is left is no longer a balloon, but a shred of rubber. Trotsky pointed out that every cook knows that the quantity of salt affects the quality of food, insufficiency makes food insipid, excess renders it unpalatable. 8 There is a recognition of the working of this law in the old saying about the straw that broke the camel's back, and in the abbreviated reference in English idiom to the breaking point as the last straw. The point of exasperation is the limit. Freud once related the sad folk tale of a village workhorse which was weaned from the habit of eating oats by the gradual reduction of its daily ration to nothing. 9. The formulation of the law. In Capital, Marx gave credit for the formulation of the law to Hegel. Engels noted that the formulation was an act of historical importance. 1 In his Logic Hegel wrote the ordinary notion of appearance or disappearance of anything is the notion of gradual appearance or disappearance. Nevertheless, there are transformations of being which are not only changes from one quantity to another but also changes from the quantitative to the qualitative. In his encyclopedia, to the extent that quality and quantity are still differentiated and are not altogether identical, these two definitions are to some degree independent of each other, so that, on the one hand, the quantity may change without the quality of the object changing, but on the other, its increase or decrease, to which the object is at rst indifferent, has a limit beyond which the quality changes. Thus, for example, alterations in the temperature of water at rst do not affect its liquid state, but if the temperature is further increased or decreased, there comes a point when the state of cohesion undergoes a qualitative change and the water is transformed into steam or ice. It seems at rst that the quantitative change has no effect whatsoever on the essential nature of the object, but there is something else behind it, and this apparently simple change of quantity has the effect of changing the quality. 1 Hegel again. A little less, a little more constitutes that limit beyond which frivolity ceases and there appears something quite different, crime, whereby right passes over into wrong, and virtue into vice. 15 Freud explicitly accepted the operation of the law of quantity into quality in psychology. For example, he pointed out, a surplus of sexual aggressiveness will change a lover into a sexual murderer, while a sharp diminution in the aggressive factor will lead to shyness or impotence. 7. Temperature and pressure. Life, as we know it, can exist only within finite limits of temperature and pressure. Even within these limits, at extreme conditions, phenomena become distorted. Jack London has left us a powerful short story describing the uncanny world of -50 degrees centigrade. B.S. Haldane has provided us with very convincing experimental evidence of the change in physiological reactions at high and low pressures. Under extreme conditions, normal physiological phenomena not only become exaggerated, but also give way to completely different ones. Even before the work of Haldane we knew that the lower limit for diving without pressurized suits is about 120 feet, and that for pressurized suits is about 300 feet. Below that we need armorized diving bells. Absolute temperature. The limits we have so far come across have been from daily life. There are also natural limits. Let us, following Maxwell's advice, interrogate nature herself. 9. In 1854, Lord Kelvin, by an inspired process of extrapolation, concluded that there is a natural lower limit to temperature, the absolute zero. The new scale of temperature was, appropriately, termed the Kelvin scale. We now know that this limit can be approached but not reached. Critical points, thresholds, and more limits. Quite early in history mankind came across critical points, the boiling point and the freezing point of water, the melting points of metals, the points of ignition of various materials, etc., although the philosophical significance of the phenomena was realized very much later. The human ear is sensitive over a wide range of frequencies, but it does not respond to infrasonic vibrations. Some do, and that, we are told, is how they get advance warning of brewing storms. Again, the human ear does not register ultrasonic vibrations, which can be heard by some insects, dogs, bats, whales and dolphins. Ultrasonic waves have various uses, for example in cleaning, cutting and the destruction of insect pests. It is now common knowledge that the sound barrier, once thought to be an insuperable limit to air speeds, is a critical point at which we have the sonic boom, and other phenomena beyond. Critical points are sometimes described in science as thresholds. There is the threshold of audibility, only sounds of sufficient intensity can be heard by the human ear, and the threshold of feeling, when the intensity is so great as to cause a painful sensation. In optics we have the well-known phenomenon of the critical angle asterisk, beyond which light rays emerging from a denser medium into a rarer are totally internally rected. From the SHI point of view, the poor SH can see the bait but not the angler. Diamond is not only the hardest natural substance, it also has the lowest critical angle. Light is therefore many times totally internally rected within a diamond to give it its characteristic sparkle. From primitive times, mankind must have wondered at the rainbow. It was only in the 17th century that René Descartes gave the explanation of the phenomenon. Incidentally, there is a critical angle also for rainbows, which cannot be formed once the sun is more than 41 degrees above the horizon. It required the genius of Sir Isaac Newton to show that the optical spectrum is the result of the breakup of white light into its constituent colors. Till his work it was thought, and taught, that white light was pure and that the colors were impurities. In 1800, Sir William Herschel, using the thermometer, extended our knowledge of the spectrum into the invisible infrared region and showed that heat and light are similar phenomena. The next year, Professor Ritter of ENA extended the visible spectrum at the other end into the ultraviolet. Ames Clerk Maxwell proved theoretically in 1864 that the visible spectrum and its extensions were only a small part of the electromagnetic spectrum. Experimental proof came with Hertz's discovery of wireless waves in 1888 and Röntgen's discovery of X-rays in 1895. High-frequency gamma rays were added after the study of radioactivity in 1896. The electromagnetic spectrum is a dynamic illustration of the law of transition from quantity into quality, with a change of quantity, an increase in the frequency of the waves, or, what is the same, with the decrease in wavelength, the quality of the radiation changes, from wireless waves, through heat, light, through its variegation from the red to violet, ultraviolet, X and gamma rays I. Di. Mendeleev found two critical points, critical pressure below which cooling alone cannot liquefy gases, and critical temperature above which pressure alone cannot liquefy gases. Independently, Thomas Andrews in Scotland discovered the same phenomena. After Pierre Curie, we have the Curie point, that critical temperature above which ferromagnetic materials lose their permanent magnetism. A law of photoelectricity states that every substance has its threshold frequency below which photoelectric phenomena cannot be observed. In these days of rocketry, every schoolchild knows that there is what is termed the orbital velocity, the necessary minimum speed to place a rocket in orbit. If the velocity exceeds the escape velocity, the rocket travels into outer space. We mention, without discussion, some other limits. Nuclear physics has its critical mass, critical volume, etc. Einstein has proved for us that the maximum velocity for a material particle or a signal can never exceed c, the velocity of light. There is the Roche limit. If a satellite, before solidifying, comes within a distance of 2.5 times the radius of the mother planet, it breaks up. 2 degree. The Indian astrophysicist S. Chandrasekhar has proved that the range of the masses of the stars is 1/8 to 20 times the solar mass. A body 1/80th of the solar mass will not be luminous. Jupiter has a mass below the critical mass and, as Gamow described it, is the largest stone in the solar system, shining, like the other planets, only by reflected light. 2 There is also an upper limit to the mass of the stars. 1 with 100 times the solar mass will be unstable. Upper limits, we are told, apply also to galaxies. Quantity and quality in the atomic world. Chemistry provided both Hegel and the Marxists with numerous illustrations of this law. Marx noted, the molecular theory of modern chemistry rests on no other foundation. 2 Engels observed, chemistry can be termed the science of qualitative changes of bodies as a result of changed quantitative composition. 25 The number of atoms of oxygen that unite with an atom of carbon determines the properties of the compound. Carbon dioxide is vital and plays a fundamental role in the life cycle of animals and plants. Carbon monoxide is fatal. Hydrogen peroxide has properties different from water. A penetrating odor near a working electrostatic machine made Martin van Marum suspect the existence of a new substance which Sean Bain named ozone. In 1886 J. Sarret found it to be a triatomic allotrope of oxygen which exists far more abundantly in the ordinary diatomic form. In 1910 chemists came across oxazone. Oxygen is vital to all forms of life, while ozone has the distinctive property of absorbing ultraviolet rays which, beyond limits, are fatal to living things. Many other elements exist in allotropic forms. A well-known example is carbon, which exists in two other forms, physically different but chemically identical, graphite and diamond. Among other examples are sulfur, phosphorus, and tin. A major factor that led to the death of the Antarctic explorer Scott in 1912 was the fact that of the 10 allotropes of tin, the one used as solder on his fuel cans disintegrates into a powder at -43 degrees centigrade. In Antarctic conditions, the solder proved worthless and Scott and his party perished in the snow. In organic chemistry there are general formulae for homologous series. For example, the paraffins can be described by the formula CH2 plus 2. For N equals L, we have methane, for N equals 2, ethane, and so on. Moreover, for small n we have gases, for medium n, liquids, and for large n, solids. Again, the alcohols have the general formula CH2 plus O. For N equals L, we have CH3O, methyl alcohol, which has important industrial uses but is injurious to health. For N equals 2, we have C2H5O, ethyl alcohol, which is intoxicating. A.M. Budelrav, unsung Russian scientist and one of the founders of organic chemistry, extended the idea of general chemical formulae to structural formulae. Different atomic arrangements within the molecule, different spatial groupings, the importance of which, as we shall see, Engels noted, give rise to isomers, compounds with the same general, but different structural formulae, and widely different in chemical properties. An example is the general formula C2H6O, which can stand for dimethyl ether, a gas, or ethanol, a liquid. It is a well-known fact that the maximum number of regular solids is V. The earliest of many outstanding discoveries of Louis Pasteur was the detection in 1848 of right-handed and left-handed crystals, which, while not asymmetrical, were mirror-symmetrical and had different properties. We mention the limit to molecular arrangements in crystalline chemical compounds. In 1881, E. D. von Fedorov, of Russia, showed that there can be only 230 types of crystals in nature. His assertion was later borne out by the X-ray analysis of crystals by von Laue and the Braggs. The Mendeleev classification of the elements. On 17 November 1869, Dmitry Ivanovich Mendeleev of the University of St. Petersburg published his tabulation of the then known 64 chemical elements according to their atomic weights. He gave each of them an ordinal number, now symbolized Z. He showed that when thus arranged, the chemical properties of the elements changed with an increase of atomic weights, and were periodically repetitive. What was more, in 1871, he predicted the existence and the properties of missing elements. His predictions were soon confirmed. In 1875 Lecoq de Boisbadran isolated gallium, in 1879, L.F. Nilsson detected scandium, and in 1886, C. Winkler discovered germanium. Experimental studies showed that Mendeleev's theoretical predictions of their chemical properties were startlingly accurate. Of the 37 elements since discovered, Mendeleev predicted the existence of 21. Mendeleev was fortunate enough to live long enough to see the addition by William Ramsay of the inert gases as group 0 of the periodic table, the discovery of polonium and radium by Pierre and Marie Curie and actinium by André Debierne. In his Foundations of Chemistry, which has been described as a masterly systematization of extant chemical knowledge, Mendeleev ventured to say, "The atoms of simple bodies are complicated substances, formed by the combination of a number of still more minute particles." Y2. T. Engels, evidently, had no first-hand knowledge of Mendeleev's work. Has no mention of it. He probably learned of its contents from his Manchester friend, the chemist K. Schorlemmer. In 1879 he wrote, enthusiastically, by means of the unconscious application of Hegel's law of transformation of quality into quantity, Mendeleev achieved a feat which it is not too bold to put on par with that of Leverrier in calculating the orbit of the then unknown planet Neptune. Engels, too, conjectured, if all differences and changes are to be reduced to qualitative differences and changes, to mechanical displacement, then we inevitably arrive at the proposition that all matter consists of identical, smallest particles, and that all qualitative differences of the chemical elements of matter are caused by qualitative differences in number and by the spatial grouping of those smallest particles to form atoms. But we have not got so far yet. 3 degrees in these remarkable lines, written in 1885, Engels was already visualizing smallest particles and their spatial grouping. With his spatial grouping, Engels the philosopher was ahead of Mendeleev the chemist. 1. Engels closed his notebooks on science in 1886. He had to edit the unished manuscripts of Marx. On the 8th of November 1895, 3 months after Engels died, Wilhelm Conrad Röntgen of the University of Würzburg accidentally discovered a hitherto unknown radiation which he called X-rays. These penetrating rays not only helped in medical diagnosis but also played a vital role in unraveling the mysteries of the atomic world. As we have already seen, discoveries followed in rapid SUCC Euro SSI 0LL. Also accidentally, in 1896, Henry Becquerel discovered another radiation which Marie Curie named radioactivity, insisting from the beginning, with the intuition of genius, that the phenomenon was atomic in origin. In 1902, Rutherford and Soddy put forward the revolutionary idea that radioactivity is the spontaneous self-transformation of the radioactive elements. Spatial grouping played an important part in the new atomic model of Rutherford and Bohr. The electrons could only occupy permitted orbits or shells in permitted numerical combinations. Also in 1913, the British physicist H.G. Moseley, after X-raying the atoms in a series of brilliant experiments, found the physical significance of ordinal number Z. It is equal to the positive nuclear charge, or, what amounts to the same thing, the number of electrons in orbit. Atomic properties change with each integral change in Z, from hydrogen to uranium, the heaviest natural atom T. In 1912 Frederick Soddy announced the existence of isotopes, atoms with different masses but with identical chemical properties and therefore occupying the same place in the periodic table. F.W. Aston confirmed Soddy's theory by fundamental exp degree 1 immense with his mass spectrograph in 1918. The explanation of this phenomenon came with the discovery of another fundamental particle, with the mass of proton, but without an electrical charge, the existence of which had been predicted by Rutherford in 1920. This particle had turned up in the experiments of Frederick Elliott and Irene Elliott-Curie, and those of Boeth and Becker. It was identified by James Chadwick in England and named the neutron. Physicists have now accumulated an impressive and rather bewildering array of elementary particles and created more complex concepts of atomic structure. Let us, for our present purposes, be satisfied with electrons, protons, and neutrons, with which we can build what has been happily called the L932 model of the atom. It is adequate for our survey. The number and spatial grouping of the orbital electrons determine the combining power or valency of the atoms, and thus their chemical properties. The mass of electrons is negligible, atomic mass comes from the nucleons protons and neutrons. While the number of protons in the nucleus of any given atom must always equal Z, the number of neutrons can vary within small integral limits and these variations give rise to the isotopes. In 1931, H.C. Urey isolated heavy hydrogen, now called deuterium, with a neutron in the nucleus. Later, scientists discovered tritium, another isotope of hydrogen with 2 neutrons in the nucleus * heavy water in which deuterium combines with oxygen, arrests growth, and kills some small forms of life. The number of neutrons determines the stability of the nucleus. The last stable nucleus is that of bismuth. From polonium onward the nuclei are radioactive, that is, inherently unstable, and go through self-transformation, often through a series of self-transformations, to a stable form. In the interpretation of the AZ0M*, Frederick Soddy compared the scientists who studied radioactivity to astronomers. They could only observe, not experiment. While it is still true that radioactivity cannot be speeded up, retarded or stopped, barely 2 years after Soddy's observation, Frederick Joliot and Irene Elliott-Curie created artificial radioactivity. We now have radioactive isotopes, radionitrogen, radioaluminium, radioiodine, etc. In every case it was found that the instability was due to the number of neutrons in the nucleus. Neutrons also provided new and more effective missiles with which to bombard the nucleus. In the expert hands of Enrico Fermi, beginning with 1934, neutron bombardment produced new atomic miracles. In 1940, Fermi created neptunium, the RST artificial, transuranic, element. Others, also unstable, soon followed, among them fermium and mendelevium. The score a few years ago stood at 105. Yet, there is an upper limit to Z.I. Frankel, Bohr, and Wheeler have shown that Chen must follow the creation of transuranic elements. Fermi and his team worked the RST atomic pile on December 2, 1942. The rest is history, Hiroshima and Nagasaki. Even before some of these exciting discoveries, at the Mendeleev Congress in 1925, Trotsky claimed, in Mendeleev's periodic law, in the chemistry of radioactive elements, the dialectic celebrates its own more outstanding victory. The next year Trotsky made a prediction of the future use of atomic energy. A biographer, Isaac Deutscher, has commented that Trotsky was the RST politician to refer to atomic energy at a time when even scientists dared not dream of the many discoveries and achievements to come. Quantity and quality in the world of biology. Biology is a source of some graphic illustrations of this law. Let us begin with a few homely examples. Darwin in his The Formation of Vegetable Mold through the action of worms showed how small causes acting for a long time produced great results. Darwin also gave the example of short-billed pigeons. When beaks get too short the chicks cannot break through their shells by their own efforts and have to be helped to hatch out by the breeder himself. 37 In his Mendeleev commemoration lecture Trotsky said of Darwin, this highly gifted biologist demonstrated how an accumulation of small quantitative variations produced an entirely new biologic quality. 3. The fertility of animals and plants. Hyman Levy gave the simple instance of a pair of rabbits taken to Australia at the end of the late century as pets multiplying so much that the offspring have become pests. 4. There are many other examples of the runaway population explosion of non-endemic species, the American gray squirrel in England, the Indian mongoose in Jamaica and sparrows in California. 42. While such examples may be explained by ecological imbalance, the fact is that, as Darwin observed, there is no exception to the rule that every organic being naturally increases at so high a rate that, if not destroyed, the earth would soon be covered by the progeny of a single pair. 43 As early as 1740 Carl Linnaeus pointed out in De Tellure that an annual plant would, in the 20 years, have 1 million offspring. A 6-foot female cod lays about 6 million eggs which hatch out in 20 days. Ling, another 6-foot sh, lays some 20 million. 45 As to quick breeding house size, the theoretical results are horrifying. Each couple will have 20,000 offspring each month, yet there are many factors that hold the growth of population of species in check, so that under normal circumstances, the numbers are maintained more or less constant. This basic fact is one of the cornerstones of Darwin's theory of evolution. As Darcy W. Thompson has observed, but multiply as they will, these vast populations have their limits. They reach the end of their tether, the pace slows down, and at last they increase no more. Their world is fully peopled, whether it be an island with its swarm of hummingbirds, a test tube with its myriads of yeast cells, or a continent with its millions of mankind. Growth, whether of a population or an individual, draws to its natural end. 7. Malthus' theory of overpopulation. In 1789 there appeared in England a book by Reverend T.R. Malthus entitled Essay on the Principle of Population, the central proposition of which was, population when unchecked, increases in a geometrical ratio. Subsistence increases only in an arithmetical ratio. A slight acquaintance with numbers will show the immensity of the RST power in comparison with the second 48. The Reverend's acquaintance with numbers was, as admitted, very slight. The law of growth of human population is not the simple law of geometric progression, nor is the growth of subsistence arithmetical progression. Malthus had, perhaps, good reason for his alarm. The rate of growth of population in England was constant till 1750. With the Industrial Revolution came a population boom, the rate of growth increased, and the population, which was 6,500,000 in 1750, rose to 16,300,000 in 1801.49. Still, even these figures do not support Malthus' contention that population in general would double itself every 20 years. The important aspect of the matter was not the parson's misunderstood arithmetic. His argument was politically motivated. He provided a pseudoscientific argument for the reactionaries of his time, and also ours. Marx observed that Malthus' arguments were directed against the French Revolution and the contemporary ideas of reform in England. 5. While granting that Malthus' theory provided a stimulus, Marx exposed him as a plagiarist, a bought advocate responsible for a libel on the Hunan race. 5. Marx pointed out that the theory is anthropocentric and also misanthropic. Why single out human beings for fertility and proliferation? Marx emphasized that there is no abstract law of human population, every stage of development has its own law of population. 3. Engels noted, the pressure of the population is not upon the means of subsistence but upon the means of employment. Mankind could multiply more rapidly than bourgeois society can demand. To us, a further reason for declaring this bourgeois society a barrier to development which must fall. 54. Charles Darwin happened to read Malthus in October 1838. After some years of careful thought, he drew a theoretical conclusion from the mass of material he had collected: there is a survival of the fittest in the struggle for existence. It must be noted, however, as Marx did, that while Malthus singled out man for proliferation, Darwin recognized that the phenomenon applied, theoretically, to all animals and plants. This, incidentally, is a classic example of an erroneous idea sparking off a profound theory. Mendeleev dismissed the theory of overpopulation as Malthusian gibberish. The more the merrier. He is said to have declared, citing facts and figures to prove that, theoretically at least, there was ample room for expansion of productive forces to support an increasing population of Russia on growth and form. Darcy Wentworth Thompson discusses the rate of growth of population and, while admitting that Malthus posed an important problem, dismisses the theory as based on very slender evidence. We have seen Thompson's observation that growth is not without its limits, that it has its natural end. 47 Vitellit implied and Verhulst clearly stated that there is a built-in retardation factor proportional to the growth factor. In 1838, Verhulst used the S-shaped logistic curve of Edward Wright to describe the growth of population. This curve grows from an asymptotic minimum to an ill-defined asymptotic maximum. That this dialectical thinking was also scientifically correct is proved by the fact that the predictions based on it proved accurate. Verhulst in his time predicted that the limit of the population of France would be about 40 million and that of Belgium about 8 million. The figures turned out to be true a century later. Impossible worlds *. Being accustomed to visual perspective from infancy, we readily accept the concept of geometrical similarity. Objects farther away, toys, miniatures, drawings, photographs and maps have reduced linear dimensions. By extension, we accept the geometrical similarity in enlargements, large-scale paintings, sculptures and the projections of the cinema. As Darcy W. Thompson has observed, we accept the proportions of the real world from whichever end of our binoculars we view it. Degree geometrical reductions and enlargements are termed, in mathematics, homothetic transformations. It was Galileo who was the RST to realize and point out, in one of his discorsi, the impossibility of a physical similarity corresponding to the geometrical. He introduced the concept of similitude or dynamical similarity. He began from an elementary arithmetical fact known at least from the time of Archimedes: when a linear dimension is doubled, the surface area is quadrupled and the volume increases 8 times. This elementary consideration is of great importance in science. It is the basis of the theory of measurement, of the theory of units and dimensions. It features in the study of models in hydraulics, ship and aeroplane construction. As Thomson has pointed out, it should have been used, after Galileo and Borelli, in the study of nature, but unfortunately was I-101. Let us follow, for a while, the trend of thought in Chapter 2 of Thomson's classic. Jonathan Swift's Lilliputians were aware of geometrical similarity. Gulliver being 12 times their linear dimensions, they allowed him 1,728 times their own quota of food and wine. Swift, Thomson observes, was unaware of Galileo's principle of similitude. Else, he would not have written, so, naturalists observe, a flea hath smaller fleas that on him prey. And these have smaller fleas to bite em. And so on ad infinitum. Lilliputians, Brobdingnagians, and Swift's innate series of Eas are physically impossible creations of the artist's imagination. So also are Tom Thumb of the Brothers Grimm and Lewis Carroll's Alice who grows or shrinks according to the eat me, or drink me, formulae. Homothetic transformations do not occur in nature. Scale imposes limitations on, and is a determining factor of, form. Long before the discovery of the Californian sequoia and the pines of British Columbia, Galileo sagaciously suggested, as it turned out, accurately, that the maximum height of a tree could be about 300 feet. Axe beanstalk can exist only as a fairy tale fantasy. Carl Bergman showed why the mouse is the smallest possible land animal and that there are no small animals in the sea. Warm-blooded whale calves, bomb in the cold sea, have to be about 25 feet long and weigh about 20 tons. For the same reason, there are no small animals or birds in the Arctic and Antarctic. Only insects and small birds are capable of stationary or hovering height. Even if ostriches were equipped with large wings, their minimum speed for takeoff would have to be about 100 mph and they would, as with large aeroplanes, require a long runway, not provided by nature. Body weight increases as the cube of, and the cross-section o. The bones only as the square of the increase in the linear dimension. B.S. Haldane pointed out that our fairy tale giants could not take a step without cracking their bones. For the same reason, elephants, rhinoceros, and hippopotamus have, of necessity, stocky legs, while giraffes have small bodies. The dinosaurs, whose shape and size were adapted for swamp life, became creatures of the past when the swamps dried up. 3 At the other end of the biologic scale, an insect cannot afford to get wet. A thin lm of water will have a weight out of proportion to the weight of the poor insect. Insects must, of necessity, have multiple or compound eyes in order to allow for the effects of diffraction. As a result, the proverbial beeline is not a straight line but the arc of an equiangular spiral. Montage. Some aspects of the law of transition from quantity to quality were not only implicitly understood but also explicitly used by some ancient people. 2 Chinese pictograms give rise to an ideogram. For example, tree plus tree equals forest in Egyptian hieroglyphs, I plus water equals tears. The hieroglyph for 1 million was, appropriately, an astonished person. All children are taught to count on their fingers. Some genius in pre-Roman times counted 1, 2, 3, 4, hand, and the notation for VE was the ideograph of the hand. V Roman numeration was decimal, notation quintal. The ideograph for 10 was 2 hands, V plus V equals X. In some primitive languages, the word for 10 is 2 hands, or sometimes, by extension, man. 7 Sergei Eisenstein, the great LM director, based his theory of montage on the fact that a new quality emerges from the juxtaposition of 2 LM sequences. This, he said, is true for any 2 facts, or objects, or phenomena, and quoted a tribute to the poet Browning who, out of 3 sounds could frame, not a 4th sound, but *6 Eisenstein gave credit to Lewis Carroll, who was perhaps the RST person to draw attention to the emergence of new qualities from the juxtaposition of two words in a portmanteau. In Alice Through the Looking Glass, Humpty Dumpty says, well, slithy, means lithsy and slimy. Lithe is the same as active. You see, it's like a portmanteau, there are two meanings packed up in one word. With Eisenstein we draw attention to Freud's discovery of the fact that the portmanteau effect is also observed in psychological phenomena. In his study of dreams, Freud came across condensation, the unconscious formation of fresh unities out of separate thoughts. In wit and its relation to the unconscious, Freud studies inter alia the formation of mixed words 7 degree and quotes Heine's Familienare, Disri 1is Anekdotage and Brill's Alcoholidays. Leaps. The transition from quantity to quality is not a gradual or continuous process. Our child's balloon did not burst gradually. Water boils all of a sudden, and just as suddenly does it turn into ice on cooling. Hegel drew attention to the sudden changes in nature, the breaks in continuity and the leaps from one stage to another. In his Logic he wrote, "It is said that there are no leaps in nature, and ordinary imagination, when it has to conceive an arising or passing away, thinks it has conceived them. When it imagines them as a gradual emergence or disappearance." Point 7 Changes in being consist not only in the fact that one quantity passes into another quantity, but also that quality passes into another quality and vice versa. Each transition of the latter kind represents an interruption in gradualness, and gives the phenomenon a new aspect, qualitatively distinct from the previous one. Thus, water when it is cooled grows hard, not gradually, but all at once. Having already been cooled to freezing point, it can remain a liquid only if it preserves a tranquil condition, and then the slightest shock is sufficient for it to become hard. 72 As Hegel pointed out, not only are the transitions from quantity to quality a general feature of natural processes, they are sudden changes, breaks in continuity, leaps from one state to another, nodes in the process of development and change. He added, all birth and death, instead of being a continued graduality, are rather an interruption of this, and are the jump from quantitative into qualitative change. F73 Engels repeated the point, in spite of gradualness, the transition from one form of motion to another always remains a leap, a decisive change. And added that this is true in all else, celestial and terrestrial mechanics, physics, and chemistry. Then within the sphere of life the leaps become even more infrequent and imperceptible, though imperceptible. Engels noted that nature is composed entirely of leaps. 75 Plekhanov observed, quantitative changes gradually accumulating, become in the end, qualitative changes. These transitions occur by leaps and cannot occur in any other manner. Dialectics knows full well that in nature and also in human thought and history leaps are inevitable. But it does not overlook the undeniable fact that the same uninterrupted process is at work in all the phases of change. It only endeavors to make clearer to itself the series of conditions under which gradual change must necessarily lead to a leap. Point 77 At birth the newborn of most animals lose the comforts of the womb or egg. Their supply of air and sustenance ceases suddenly. They then go through two revolutions, they begin to breathe through their noses and eat through their mouths. Insects go through metamorphoses. In his polemic against Tikhomarov, which is a neat and entertaining essay on sudden changes in nature and history, Plekhanov cited the example of the buttery. A caterpillar grows bigger day by day, but up to a point. Suddenly, it becomes a chrysalis and remains dormant for a time, until, just as suddenly, it emerges in all its beauty as a buttery. It may be argued, as Plekhanov expected, that the difference between what is gradual and what is sudden is relative, depending on the choice of time scale, and that nature makes no jumps*, but it is easy to visualize that, even within a chosen time scale, there are accelerations and, also, retardations. Thus far, we have listened to the philosophers. Engels made his observation in 1878, Plekhanov in 1889. Let us now hear the scientists. Max Planck, who, as we have seen, discovered the discontinuity of energy and put forward the quantum hypothesis, in 1900, wrote, "Recent discoveries have shown that the proposition is not in agreement with the principles of thermodynamics, and, unless appearances are deceptive, the days of its validity are numbered. Nature certainly seems to move in jerks, indeed of a very queer kind. In any case, the quantum hypothesis has given rise to the idea that in nature changes occur which are not continuous but of an explosive nature. In the eld of cosmogony, Laplace's theory of stellar evolution has been mooted by later investigations. James Jeans has observed that the shrinking of celestial bodies has not been gradual, but has been a contraction in spasms." 1. In 1864, Thomas Huxley observed that Darwin has unnecessarily hampered himself by adhering so strictly to his favorite natura non facit saltum. "We greatly suspect that she does make considerable jumps in the way of variation now and then, and that these saltations give rise to some of the gaps in the series of known forms." 3. In 1902, the Dutch biologist de Vries discovered the occurrence of mutations, sudden changes in the hereditary nature of living organisms. In 1906, Sir Jagdish Chandra Bose claimed that plant growth occurs in small, rhythmic pulsations. The law of the transition from quantity to quality and vice versa is thus seen to operate in all spheres of existence. No process can be endless, at certain stages transitions must occur, and we must not expect gradualness, but suddenness, leaps and discontinuity.